Hello there, Santi here. Welcome back to my YouTube channel. If you are preparing for data analyst or data engineering interview, stop scrolling. You have just hit the absolute jackpot. I just solved 67 free Postgres SQL interview questions directly from Stratascratch. We are covering real world problems from massive tech companies like Amazon, Meta, Deloitte, and I recorded every single solution just for you. Look, practicing random problems won't get you past a fine technical screen. You have to recognize the architectural patterns. In this masterclass, I am breaking down the exact interview traps that cause candidates to fail, including the null contraction trap, the integer division trap, multidimensional group bias, and complex Cartesian joins. Because this is a massive hours long course, I have fully timestamped each and every single question in the description below. Bookmark this video right now and treat it as your personal Postgres cheat sheet and use the chapters to jump straight to the concepts you need to practice. Drop a like for the effort it took to record this. Hit subscribe if you want to see me tackle the hard tier next. Let's jump right in onto my screen for the question number 1. Okay, let's go. Here we go, the official start of the 67 questions masterclass. We are kicking things off with a classic Facebook meta problem from Stratascratch. Okay, cut the solution. This is an easy tier question, but it has a trap built right into it that catches a lot of beginners off guard. The duplication trap. Okay, so I will read the question for you. Find all the posts which were reacted to with a heart. For such posts, output all the columns from the Facebook posts table. We are given two tables: Facebook reactions, which has poster ID, friend reaction, date, day, and post ID, and Facebook posts, which has the details of the all the posts made on the Facebook. So here is our expected output. Okay, we have to output all the posts which were reacted with an heart. Okay, to solve this, we have to connect two tables: Facebook underscore posts, which hold the text, and Facebook reactions, which holds the likes, laughs, and reactions. A single post can receive hundreds of heart reactions. If you do a single standard join between the posts and the reactions, the database will duplicate the post row for every single heart it received. To fix this, you must explicitly tell the database to only return the unique posts by using distinct keyword. So I will write the pseudocode for this first. First, initialize the select statement and pull every every column from the posts table using p dot star. Add the distinct keyword immediately to prevent duplicate rows. Second, define your primary table from Facebook underscore posts as P. Third, connect the reactions data by doing an inner join on the Facebook reactions table as R. Fourth, lock in the relationship. Finally, filter the entire dataset down to only the relevant engagements with where r dot reaction equals to heart. Okay, let's write the code. Select distinct p dot star p dot star from Facebook posts as p, join Facebook reactions as r on p dot post id equals to r dot post id, where r dot reaction equals to heart. Okay, all right. So we are starting with a classic meta product question from Stratascratch. We have a table of Facebook posts and a completely separate table logging each and every single reaction those posts receive. We need a clean list showing only the posts that received at least one heart reactions. This is an easy tier question, but it introduces our first major interview pitfall, the fan out trap. Think of how social media works. One viral post might get 5,000 hertz. If you just join these two tables together normally, the SQL will duplicate the single post 5,000 times in your final output. If you don't want to know how many hearts it got, we just want the post itself. To solve this, we start by joining the Facebook posts to Facebook reactions using their shared columns, the post ID. Then we apply our where clause to filter only the heart reactions. Beat, but to beat the fan out trap, we go right back to our select statement and drop in this distinct keyword. This acts as a final bouncer at the door, ensuring that even if a post got a million hearts, it only shows up in our final dashboard exactly one. We run it and our code is accepted. Now let's move to our question number 2, consecutive days. It is an hard level question asked in Netflix. Okay, here is our question number 2. It is an hard level question, consecutive days. Find all the users who were active for 3 consecutive days or more. We are given the SF events table, which has the record date, account ID, and user ID. We have to find out the users who were active for 3 consecutive days or more. Okay, so first I will start by writing the pseudo code for this. Okay, it is this is it. It is an hard level problem, and it tests one of the most highly sought after concepts in data engineering interviews: sequential pattern matching. To solve this, we are going to use one of the most powerful tools in SQL, Windows function. Okay, the Windows function blueprint. There are exactly two massive traps here. The same day trap. A user might trigger three events on the single day. That doesn't mean that they were active for three consecutive days. We have to strip away the noise and find their unique active days first. Okay. How second trap, the streak trap. How do you compare rows to the other rows? If you try to use self join, your code will become unreadable, tangled mess. The fix. We will use the lead window function. If we order a user's activity chronologically, lead allows us to look exactly two rows in the future. Because we already removed duplicates, if the date exactly two rows down is exactly two calendar days away, boom, we have a guaranteed 3 day streak. So first I will write the pseudo code. Okay, first open a CTE called daily activity. Use select distinct user ID record date to guarantee we only count one record per user per day. Second, open another CTE called streak check. Select the user and the date, and then introduce the lead window function. Third, configure the window lead record date, comma 2 to look two rows ahead. But partition this by user ID so we don't mix up different users, and order it by record date chronologically. Fourth, write the final select distinct user ID. We use distinct again just in case a power user has multiple separate 3 days streak. Finally, the magic filter where day underscore 3 equals to record date upon 2 divide by 2 record day plus 2 if the third active day is exactly 2 calendar days after the first day active day, it is mathematically impossible for the streak to be broken. Okay, I will write the code now. Okay, with daily activity as step 1, remove multiple events on the same day. Select distinct user ID, record date from SF events. Okay, another CTE streak check as step 2, look exactly 2 activity days into the future. Select user ID, user ID, and record date and lead record date, comma 2 over partition by user ID order by record date as day 3 from daily activity, daily daily underscore activity. Okay, step 3, check if the future date is exactly 2 calendar days away. Select distinct user ID from streak check where day underscore 3 equals to record date plus 2. All right, now this question asks us to find active users for 3 consecutive days. We have a massive we have a massive raw event log where users might trigger 10 events a day or disappears for weeks. We need a single deduplicated list of power users who hit that 3-day streak. Okay. The question is notorious Fang filter. because it contains two traps. The first is the same day trap. If you just count events, a user who clicks 3 times on Tuesday will look like a 3 day streak. We have to squash that immediately by selecting distinct user ID and date inside our first city. The real challenge is comparing dates across multiple rows. Beginners try to join table to itself 3 times. Don't do that. It's terribly inefficient. The solution. Instead, we are going to use SQL's time machine, the lead window function. Inside our second CTE, we use lead and offset it by 2. We are telling the database, hey, look at my current date and fetch the date exactly 2 active days in the future. We partition this by user and order it by date. Now the final check. Because we already forced every row to be a single unique day. If the future date is exactly equal to our current date plus 2, we have guaranteed unbreakable 3 day streak. We add a final distinct on the output to handle users with multiple streak. We hit check solution and okay, it is not accepted. Line number 19. Okay, partition. We check our partition. We check our solution and our solution is accepted. We move to our next question. Question number 3. Best selling item. Question number 3. The best selling item. Okay, I will clear out my previous solution. Okay. Find the best selling items for each month. No need to separate months by year. The best selling item is determined by the highest total sales amount calculated as total paid equals to unit price into quantity. A negative quantity indicates a return or cancellation. The invoice number begins with C. To calculate sales, ignore returns and cancellations. Output the number, output the month, description of the item, and total amount paid. So we are given an online retail table which has invoice number, stock code, description, invoice date, country, unit price, etc. and quantity as well. Here is our expected output. We must output the best selling item for each month. Okay, so first I will write before writing the pseudo code, I will explain you about this question. It is a phenomenal problem because it tests your ability to combine aggregations with window function, a combination that FANG interviewers absolutely love. Here is the blueprint. The aggregation ranking blueprint. The trap. There are two major pitfalls in this question. The ghost revenue trap. The dataset includes returns and cancellation, negative quantities, and invoice numbers starting with the letter C. If you just blindly multiply the quantity with the price, those negative numbers will destroy your revenue calculations. You must filter them out before doing any math. The max illusion. Beginners try to solve this by grouping by month and using the max total paid function. But the max only gives you the number, it drops the entire item description. To keep the item name attached to the highest revenue, you must use the rank window function on the top of the grouped data. So first I will write the pseudo code. First open a CTE called monthly sales. We need to calculate our base metric first. Base metric first. Second, extract the month from the date, and select the description. The description. Third, calculate the revenue, sum of unit price into quantity. But immediately apply a where clause where quantity is greater than 0 and invoice number not like. See percentage where quantity is greater than 0 and invoice number not like. See percentage to completely eliminate returns from our math. Fourth, the magic step. Introduce the rank. Partition the window by the extracted month and order it by our revenue calculation in descending order. Finally, close the CTE and write a simple select statement pulling the month and description and the total paid, adding where rank is equals to 1 to only show the absolute best sellers. Okay, now I will write the code for this first with monthly sales as select. Okay, first what we are doing is step 1 and 2, filter the noise. Group the data and rank the results. Select extract month from invoice date as month. Description sum of unit price into quantity. unit price into quantity to quantity as total paid rank over partition by partition by extract month from invoice date, month from invoice date, order by sum unit price into quantity in descending order as rank as RNK from online retail where quantity greater than 0 and invoice number not like C percentage group by 1 comma 2. Step 3, filter for only the number 1 ranked items. Select month, description, total paid, from monthly sales where rank equals to 1. Alright, and this is an hard tier e-commerce problem. We had a we have a massive raw ledger of every single transaction, including items that were returned or cancelled. We need a clean month by month report showing which item generated the most revenue. The concept trap. There are two traps here that will immediately fail you in an interview. First is the ghost revenue trap. If you look closely at the data, the cancellations are stored as negative quantities with the invoice starting with C. If you sum this up without filtering, your revenue numbers will be completely wrong. The second trap is the max illusion. A lot of candidates try to use the max aggregation function for the highest revenue. The problem: max isolates the number, but it leaves the item description behind. We need a way to keep the item attached to its revenue score. To solve this, we are going to combine an aggregation with a Windows function inside a CTE. First, we handle the data cleanup. We use extract to isolate the month. We add a strict where clause, quantity greater than 0 and invoice number not like C percentage. And boom, returns are gone. Next, we calculate our total revenue and drop the rank window function. We tell SQL to partition our data by month and rank the revenue from highest to lowest. Because we do this inside the CTE, our output now has a clean ranking column for every single item. Finally, we step outside the CTE, do a simple select, filtering where rank equals to 1, run the code, and You just generated a flawless boardroom ready sales report. Okay. Next is our question number 4, rank variance per country. Okay, here is our question number 4, rank variance per country. I will first remove my solution. Okay, rank variance per country. Compare total of number of comments made by users in each country during December 2019 and January 2020. For each month, rank countries by their total number of comments in descending order. Countries with same total should share the same rank, and the next rank should increase by 1 without skipping numbers. Return the name of countries whose rank improved from December to January. That is, their rank became smaller. Okay, we are given two tables. Facebook active users, which has all the user details like user ID, name, status, and country. And another table is Facebook comments count, which users has made how many comments on what date. It is the every users count. Here is our expected output. Okay. We have to return names of countries who rank improved from December to January. It is Mali. Okay. So alright, this question focuses on an extremely common analytical request, period over period comparison. But there is a very specific terminology trap hidden in the instructions that interviewers use to test if you actually know your window function. Here is the blueprint, the dense rank blueprint, the trap. Read the instructions carefully. Countries with same total should share the same rank and next rank should increase by 1 without skipping numbers. Most candidates blindly use the rank function here. If two countries tie for the first place, the rank assigns them both 1 but skips the next number, making the next country 3. The instruction without skipping numbers is a massive flashing neon sign telling you that you must use dense rank. The fix. We are going to build this in three distinct phases. First, we aggregate the monthly totals. Second, we apply dense rank. Finally, we use a self join to place December's rank and January's rank side by side on the exact same row so we can mathematically compare them. Okay, the on screen pseudocode is here first. Okay, first create a CTE called monthly summary. Join the user table to the comments table. To the comments table, filter strictly filter strictly for December for December 2019 and January 2020. Group by the country and the extracted month and sum the comments. Second, create a second CTE called ranked summary. Pull your country and month and apply dense rank. Partition by the month number and order by total comments in descending order. Third, write the main query and initiate a self join. We query the ranked summary CTE and alias it as DEC for December and join it to itself aliased as Jan, connecting them on December dot country equals to Jan dot country. Fourth, lock in the time frame in the where clause. Finally, write the winning logic and Jan dot rank is less than December dot rank. Now I will write the code first. With monthly summary as step 1, aggregate total comments by country and month. Select u dot country, comma, extract month from c dot created at, extract month from c dot created at as month num sum c dot number of comments as total comments from FB active users as you join FB comments count as C on u dot user ID equals to C dot user ID where c dot created at is greater than equals to 20191201 and c dot created at is less than equals to 2020 0131 group by 1 comma 2 ranked summary as step 2 apply dense rank partition by month select country month num dense rank over partition partition by month num order by total comments in descending order as rank step 3 self join to compare January's rank against December December's rank select dec.country from ranked summary as dec join ranked summary as jan on dec.country equals to jan.country where December dot month num equals to 12 and jan dot month num equals to 1 and jan dot rank rnk is less than December dot rank. All right, this is a classic meta-analytics problem, period over period variance. Okay, we have a raw log of active users and their daily comment counts. We need a final. We need to find exactly which countries improved their global ranking from December to January. The concept trap. Here is the massive vocabulary trap hidden inside the prompt. It says the next rank should increase by 1 without skipping numbers. If you use standard rank function, the two countries tie for the first place. SQL skips the number 2 and give rank 3 to the next country. Your calculation will be thrown off. You have to recognize that without skipping numbers, if interviewer code for the interviewer code is dense rank. The second challenge is comparing two different time periods. SQL compares row vertically, not horizontally. To keep a rank, to see if a rank improved, we need to force December's rank and the January's rank onto the same exact row. To do this, we use a three-step architecture. In our first CTE, we join our tables, filter for our 2 months, and sum up the comments by country. Standard aggregation. In the second CTE, we drop in our dense rank function, partitioning it by month so the rank reset perfectly. With the calendar, when the calendar flips to January, finally the master stroke, the self join. We call our CTE and alias it as December and join it right back to itself, aliased as January. By joining on the country name, we just pivoted our data. We can now compare them directly in our where clause. We say Jan.rank is less than December.rank because a smaller number means a better rank. We hit check solution. Okay, line number 24. Syntax error. Okay, and in line number 33 and line number 22, country doesn't exist. Okay, from from monthly summary, monthly summary. All right, we have our exact list of rising countries. So question number 4 is was definitely very good and it's over. Let's move to our next question. Question number 5. Find updated records. So here is our question number 5. Finding the updated records. We have a table of employees and their salaries. However, some of those records are old and contain outdated salary information. Since there is no timestamp, assume salary is non decreasing over time. You can record the current salary of the employee. You can consider the current salary of the employee is the largest salary among their records. If multiple records share the same maximum salary, return any one of them. Output their ID, first name, last name, department ID, and current salary. Order your list by employee ID in ascending order. Okay. We are given an MS employee salary table. It is an raw table which contains details of employee ID, first name, last name, salary, and their department ID. And here is our expected output. We had to output the salary in the ascending order of the employee ID. Okay. So while the logic in this question is straightforward, this problem tests a fundamental SQL rule that catches thousands of beginners in live interviews. The aggregation grouping rule, the aggregation blueprint, the trap. The instructions The instructions state there that there is no timestamp, but we can assume that current salary is the maximum salary. The trap is how SQL handles combining aggregated data, like max salary, with non aggregated data, like names and IDs. If you write a select statement with max salary, but forget to tell SQL exactly how to group the remaining columns, the database will throw a fatal syntax error. The fix: you must explicitly declare every single non-aggregated column in your group by clause. By grouping the employee's ID, first name, last name, and department together, the max function perfectly collapses their historical salaries into a single current maximum. Okay, so I will write the SQL solution directly. Select ID, first name, last name, department ID, salary, max of salary as current salary from MS employee salary group by ID, first name, last name, department ID, order by ID in ascending order. Alright, so let's tackle this question number 5. We are back with the easy tier with a classical HR database problem. We have an employee table cluttered with historical outdated salary records and no timestamps to guide us. We need a clean deduplicated list showing only the absolute highest and therefore must and therefore must most current salary of each person. The question is testing very specific fundamental rule of SQL: how to mix column, how to mix normal columns with aggregated columns. The prompt tells us to find the highest salary value, which screams max salary. But here is where beginners fail live interviews. If you ask SQL to find maximum salary, but you also ask it to print employee's name and ID, the database panics. It doesn't know how to squash multiple historical rows into one without explicit instructions. If you leave out your group by clause, your code will crash. The fix is simple but strict. In your select statement, we pull the names, IDs, department. Then we drop in our max salary function. To prevent crash, we immediately go down to our group by clause, list our every single column that isn't being aggregated. By grouping the ID, first name, last name, and department together, we tell SQL exactly how to collapse those duplicate rows. Finally, we add an order by an ascending order to format the report properly. We hit check solution. Okay, our solution is not accepted. Okay, why is it not accepted? Let me check it. Okay, in this question, an employee has different department ID. Okay, we have to rewrite our solution because in the solution an employee's department can be changed. So we will have to use CT table to get the solution with salary rank CTE as select ID, first name, last name, department ID, salary, rank over partition by partition by ID, order by salary in descending order as rank from MS employee salary select ID first name last name department ID salary from salary rank CTE where rank equals to 1 where rank equals to 1. Alright, when I hit check solution, yeah, our solution is accepted when we have created the salary rank CTE. Then we ranked the salary in descending order and we got outside the CTE to get the ID first name, last name, and department ID salary from salary rank CTE where rank was equals to 1. Alright. So let's move to our next question. Question number 6. Users by average session time. So I will clear out the solution first. Users by average session time. Calculate each user's average session time, where a session is defined as the time difference between page load and page exit. Assume each user has only one session per day. If there are multiple page load or page exit events in the same day, use out the latest page load and earliest page exit. Only consider the sessions where the page load occurs before page exit on the same day. Output user ID and average session name, average session time. So we are given the Facebook weblog table. It has the user ID, timestamp, and the action what they have taken. And here is our expected output. We have to give the average session duration of each user. Okay. So it is a classic Facebook product analytics problem. The question tests one of the most critical skills in data analyst must have sessionization. The fundamental problem here is that event logs are recorded vertically, one row per action. But to calculate durations, you need to do math horizontally across columns. Here is your blueprint, the horizontal pivot blueprint. If you look at the raw event log, a user's page load and page exit are stored on a completely different separate rows. You cannot easily subtract the timestamp of row 1 from row 2. Furthermore, the prompt gives us messy data rules. Users might have multiple loads or exits in a single day, and we specifically need the latest load of and the earliest exits. The fix. We have to force the vertical data onto horizontal format using conditional aggregation. We group the data by the user and the calendar date. We can use case when statements wrapped in max and min functions. This creates dedicated columns for latest load and earliest exit at the same row, allowing us to subtract them. So here is the bulletproof SQL solution with with daily sessions as step 1. Pivot the vertical logs into horizontal daily columns. Select user ID, date, timestamp as session date, max of case 1 action, case 1 action equals to page load, then timestamp and as latest load, latest load, minimum of case when action equals to page exit, page exit, then timestamp and as our earliest exit from Facebook weblog table, group by group by 1 2. Step 2, calculate the session durations, the session durations and find the overall average per user. Select user ID, average of earliest earliest exit minus latest load as average session time from daily sessions where where latest load is not null and earliest exit is not null and latest load is less than earliest exit, group by user underscore id. All right all right we are at the question number 6. This is a real meta product question focusing on sessionalization. We have a massive Facebook weblog, a vertical event log where page load, scrolls, exits are all stacked on the top of each other. We need a clean dashboard showing the average session duration for each single user. Okay, the concept track. The question is designed to test how you handle vertical event logs. You can't not just subtract row 1 from row 2 to find time difference. Plus, the prompt gives us a massive headache. It says user might trigger multiple loads and exits on the same day, and we specifically need to find the difference between latest load and the earliest exit. To solve this, we have to pivot our data horizontally so that the start time and the end time sit side by side on the exact same row. The solution. We do this inside a CTE using conditional aggregation. We group our data by the user and the calendar date. Then we use a case when statement to isolate the page load actions and wrap it in max function to guarantee we only grab the latest timestamp. We do the exact same thing for page exit but wrap it in a minimum function to grab the earliest one. Now our messy logs are perfectly organized into a single row per user per day. We step outside the CT, subtract the load from exit, and wrap it inside the average function. We drop a strict where clause to guarantee the load actually happened before the exit. We hit check solution, yeah, and we have a flawless average session time. Now let's move to our next question, question number 7, acceptance rate by date. Alright, I will clear my solution first. Okay. Acceptance rate by date. It is a medium level question. Calculate the friend acceptance rate for each date when the friend requests were sent. If friend a request is sent if sent equals to action and accepted if action equals to accepted. If a user is not if a request is not accepted, there is no record of it being accepted in the table. The output will only include dates where requests were sent and at least one of them was accepted. Okay, so we have a FB friend requests table. It has user ID of the sender, user ID of the receiver, date when it was sent, and the action. And here is our expected output. Okay, we have to find the of percentage of the accepted requests by day. Okay, this is another classic meta question from Stratascratch that tests our ability to track the life cycle of an event across rows. Okay, the life cycle blueprint, the trap. There are two massive traps in this question. The timeline mix-up. The prompt asks us for the acceptance rate by date, by the date the request was sent. If you try to group the raw table by date, you will mix together sent date and the accepted date into a single bucket, completely destroying your metric, the denominator trap. To find the rate, you need to divide the number of accepted requests by total number of sent requests. If you use any inner join to match them up, you instantly delete all the ignored requests from your dataset, leaving you with only the 100% acceptance rate every single time. The fix. You must split the table in half using CTEs, one for the sent action, other for the accepted actions. Then you connect them using left join. This preserves the total denominator while allowing you to count the successful acceptances. Finally, we beat the integer division trap by multiplying with 1.0. Okay, here is the bulletproof SQL solution. With sent requests as step 1, isolate the sent actions to log in the current date. Select date as sent date, user ID sender, user ID receiver, user ID sender, user ID receiver, from FB friend requests, where action equals to sent, accepted requests as step 2. Isolate the accepted actions. Select user ID sender comma receiver comma receiver from FB requests where action equals to accepted. From FB friend for IEND requests where action equals to sent is equals to accepted. Step 3. Left join to preserve the total sent and calculate the rate. Select s dot sent date as date count a dot user id receiver into 1.0 upon count s dot user id sender as percentage acceptance from sent requests as s in left join accepted requests as a on s dot user id sender equals to a dot user id sender and s dot user id receiver user id user id receiver equals to a dot user id receiver group by s dot sent date having count of a dot user id receiver greater than 0. Alright, now I will explain you the solution. We had a massive messy event log tracking friend request, send request and accepted requests are stored completely in different rows, often on totally different dates. We need a clean date by date breakdown of friend request acceptance rate, especially tied on the date the request was originally sent. The question is absolute minefield. If you try to group the data by date, your metric will instantly break because you are mixing sent date with accepted dates. We have to separate the life cycles. The second trap is inner join reflex. If you separate the data but join them back together with inner join, you will accidentally delete every single friend request that was ignored. You can calculate a percentage if your denominator goes missing. How can you calculate a percentage if your denominator goes missing? To build this defensively, we split the logic into two CTEs. One CTE isolates all the sent actions. This becomes our master timeline. The second CTE isolates all the accepted actions. Then we stitch them together using left join. We start with send table and try to attach the accepted table by matching both sender and receiver IDs. If a request was ignored, the accepted column just populates with nulls, which is exactly what we want. Now we group with our send date and run our calculation. The count of accepted receivers divided by count of sent receivers multiplied by 1 to force decimal math. Finally, we throw a having clause to filter out dates with zero acceptances. When we hit that solution, we have a perfectly airtight funnel metric. Alright, so we move to our next question, finding user purchases. So let's move to our question number 8. So our question number 8 is finding user purchases. It is a medium level question. So first let me read the question. Identify returning active users by finding users who made a second purchase within 1 to 7 days after their first purchase. Ignore same day purchases. Output a list of user IDs. So we are given an Amazon transactions table. It is a massive table of transaction. A user might buy something on Monday, nothing for a month, then buy something again. So we are given ID, user ID, item created at what date the user bought the item, and revenue. Okay, and our expected output is this, just a single column of user ID. We need a clean, deduplicated list of unique user IDs for people who form a specific habit, making a follow-up process within making a follow-up purchase within 1 to 7 days of a previous purchase. So these users have made a purchase within 1 to 7 days of a previous purchase. So first I will start by writing the pseudo code. First I need to look at each user's personal timeline of purchases in chronological order. Next, for every single purchase they make, I want to peek into the future and see the exact date of their very next purchase. Then I will calculate the difference in days between the current purchase and the next purchase. Finally, if the gap is between, finally, if the gap is between 1 and 7 days, I will grab that user's ID and make sure I don't output I don't output duplicates. So I will first start by writing the code with next purchase CTE as select user ID comma created at lead created at lead created at over partition over partition by user ID order by created at as next purchase from Amazon transactions. So I will get out of this CTE select distinct user ID from next purchase CTE where next purchase date minus created at between 1 and 7 1 and 7. So I will explain you this code before. So this is a classic Amazon retention problem today. We have a massive table of transaction. A user might buy something on Monday, nothing for a month, then buy something again. We need a clean deduplicated list of unique user IDs for the people who form a specific habit, making a follow-up purchase within 1 to 7 days of purchase of previous purchase. To compare to compare a row with a future row, we use lead window function. Inside our CTE, we write lead created at over partition by user ID order by created ID. This bundles the data by the users, sorts them sorts their purchases chronologically, and literally pulls out the date of their next purchase onto the same row as the current purchase. We now have created at and next purchase date sitting side by side. Now we step outside the city and do something incredibly simple. In Postgres SQL, date math in our where clause. Next purchase date minus created at. In Postgres, subtracting two date automatically gives you the exact number of days between them. We use the between 1 and 7 operator to instantly filter out same day purchases and anything taking longer than a week. Lastly, a user might trigger this 1 to 7 day rule multiple times a year. If we just select user ID, we will get duplicates. We wrap it up with select distinct user ID to give the interviewer exactly what they asked for, a clean, unique list of active returning users. So I will run my code now. Okay. Line number 15. Next purchase date does not exist. Next purchase date does not exist. Next purchase next purchase date exists. Okay. So I will check my solution. I hope it is fine. Then I will post it. Solution is incorrect. For a solution to be accepted. Okay, this is right solution. What is my solution? 111 112 111 के बाद 114 आएगा क्या? इसका क्या है? इसमें क्या दिक्कत आ गई? Let me check why this code is giving the wrong answer. Okay, what error we are getting here is, so in the previous code which used lead window function, which checks the time gap between any consecutive purchases. Imagine a user buys an item on January 1st. 6 months go by. Then they buy an item on June 1st and second on June 3rd. The lead function sees the 2 day gap in June and says, hey, they have bought something within 7 days of their last purchase and includes them. But that was their and sixth fifth purchase. We completely ignored the prompt's strict condition to measure only from the first purchase, which resulted in the 4 extra users. We need to scrap lead entirely. Instead, we must find the absolute first day they ever shopped and compare every other transaction to their basic to their specific baseline. Okay, so I will write this code again with first purchases as select user ID user user ID comma minimum of created at created at as first date from Amazon Amazon transactions group by user ID select distinct t dot user ID from Amazon transactions as t join first purchases as first purchase fp on t dot user id equals to fp dot user id where t dot created at minus fp dot first date between 1 and 7. Okay, hopefully let's check our solution and it is accepted. So what we did here was, now 90% of the people will look at this at this time window question and try and immediately try to solve it using lead window function to find gap between consecutive purchases. If a user makes their first purchase in January, then makes second back-to-back purchases 6 months later in June, lead will see the June gap and include them. But the prompt strictly asked us for the gap after their first purchase. If you use lead, you will fail the hidden test cases and we will have a complete different approach. Okay. First, I will explain you the baseline CTE, finding the to ensure we are strictly looking at the start of the user's journey. We build a CTE called first purchases. We use a simply group by user ID and apply minimum created at function. This instantly compresses their entire transaction history and leaves us with one single absolute baseline date, the exact day they made their first purchase. So then we move outside our CTE. Now we step outside our CTE and join our newly found first date back with the main Amazon transactions table on user ID. This places a user's first purchase date right next to the every other transaction they have ever made. Finally, we do our date math in where date clause created at minus first date in Postgres SQL, subtracting two dates gives you the exact number of days between them. By wrapping it in between 1 and 7, we mathematically guarantee the purchase happened within a week of their initial start date, automatically ignoring same day purchases. Lastly, a user might buy 5 things in the first week. If we just select the user ID, we will get duplicates. We wrap it up with select distinct user ID to give interviewer our final clean list of active returning users. Okay, so let's move to our ninth question. Okay, so let's let's move to our question number 9. It is total cost of the orders. It is an easy level question. So let me read out the question first. Find the total cost of each customer's order. Output customer's ID, first name and total order cost. Order records by customer's first name alphabetically. Okay, so here is the expected output. We have to give ID, first name, and sum of the total order cost of that customer. We have two tables given. First is customers table. It has, okay, one is the customers table and their personal info like last name, city, address, phone number, etc. And second table we have is orders table. It has customer ID, order date, order details, and total order cost. Okay, what do we need finally? We need a single clean report that shows each customer's ID, their first name, and total amount of money they have spent with us. Sort name, sort alphabetically by their name. Okay. So first I will write the pseudocode of this. First, I will first I need to connect the customer table to the order table so I can see who bought what. Okay, then next next I need to bundle all the purchases together for each specific person. For each specific person, then I will add up the costs of all those purchases to get their grand total. To get their grand total. Finally, I will alphabetize the entire list by the customer's first name. Okay, I will start by writing my code. So I need so I need uh, customer ID. So I need select c dot id, comma c dot first name sum o dot total order cost as sum from customers as c inner join orders inner join orders as O on C dot ID equals to O dot customer ID group by group by C dot ID comma C dot first name order by C dot first name ASC. Okay, I will run my code. It looks fine. Okay, so I will explain you the code again. Actually, no need of explaining the code again. I will check the solution and our code has been accepted. So let's move to our question number 10, which is workers with highest salaries. Okay, so all right, we are hitting question number 10. We are in our double digits today. So our 10th question is workers with highest salaries. So first I will read out this question. Management wants to analyze all employees with official job titles. Find job titles of the employees with highest salary. If multiple employees have the same salary, include all the job titles. Okay. We are given two tables. So first table is of worker. It has all the personal details and salary of the employee, like their worker ID, first name, last name, salary, joining date, and their department. And second table which we are given is title. In the second table, we have three columns: worker reference ID, worker title, affected from. We have the job title here, okay, and our expected output is this. We need a strict filtered list showing only the job titles of whosoever makes the absolute highest salary in the entire company. Okay, first I will write the pseudo code for this. Okay, first I need to connect the salary data to the job title data. First I need to connect salary data with the job title data. Dropping anyone who isn't who doesn't have a official title. Dropping anyone who doesn't have an official title. Next, I need to scan the entire company and find out what the highest possible salary actually is. Finally, I will filter filter my connected list so it only shows the job titles of the people who make the exact maximum amount. So I will start by writing my code. So select, first I want is worker title. Okay, T dot worker underscore title as best paid title from. Okay, then I will join the workers and the title table from worker as W, inner join title as T on W dot worker underscore ID equals to T dot worker underscore reference ID, where W dot salary equals to select max salary from worker. Okay, so the prompt gave us a very specific rule. The management wants to analyze only employees with the official job IDs. This is a massive hint. We start by doing an inner join between our worker table and title table. An inner join automatically acts as a filter. If an employee exists in the worker table but has no matching row in the title table, they are immediately dropped out. Okay, here is okay. Here is the massive trap most people fall into. They just try to order by salary DAC and slap a limit one at the end. But the prompt specifically warns us that multiple people might tie for the highest salary. Limit 1 would incorrectly cut off the ties. To fix this, we use a subquery in our where clause where we write where w.salary equals to select max from the worker. This forces equals to independently look up the highest salary in the company and then perfectly filters out the main query to show everyone who hits that exact number. Lastly, we just select the worker title column and alias it has best paid title to match the expected output. We run the code, handle the edge cases perfectly. Solution is incorrect. Okay. Solution is incorrect. Let me check where is the error we are getting here. Oh man, Stratascratch got us with a very brutal hidden data trap. This is why we are running against the hidden test cases is so important. So our previous code searched the entire worker table and absolute highest salary. But what is the person making? The highest salary does not have an official title in the title table because we used inner join. That ghost employee was instantly dropped from our data. Then our where clause went looking through the remaining employees asking does anyone with the highest salary? Since only one person who made that much was dropped, SQL returned the exactly zero rows. The prompt said management wants to analyze only the employees with the official job titles. This implies we shouldn't even consider the salaries of the people without titles. We must calculate the maximum salary after we filter out the ghost employees. To make this bulletproof, we are going to use our senior level ranking tool called dense rank. Okay, I will write the new code now. With ranked employee, with ranked employee as select with ranked employee as select t dot worker title comma dense dense rank over order by w dot salary in descending order as rank from worker table from worker as w inner join title as t on w dot worker id equals to t dot worker worker reference id. Okay, then we select worker title as best paid best paid title from ranked employee where rank equals to 1. Okay. So this code is accepted. I will explain you this code again. To avoid the host employee trap, we use a CTE and the dense rank window function. First, we inner join the worker and the title tables together. This instantly purges anyone without a title. Now, on the perfectly clean data, we apply dense rank over order by salary in descending order. This ranks everyone from highest earner to lowest earner. We use dense rank instead of rank so that we can get three people tied for the first place. We do not skip any numbers. The final filter. Now the hard part is over. We step outside the CTE, grab our burger title column, and simply filter with rank equals to 1. This dynamically grabs whosoever the top earners are among the title employees, returning all their job titles perfectly. This is a phenomenal learning moment. It proves exactly why Windows functions are safer than subqueries when dealing with dirty data. Okay, let's move to our question number 11. So, hi everyone, let's move to our question number 11. Our question number 11 is monthly percentage difference. It is an hard level question asked by Amazon. Okay, so this was the practice which I was doing. So, first, let me read out the question for you. Monthly percentage difference. We are given a table of purchases. We have to calculate month over month percentage change in revenue. The output should include year, month, date, and percentage change rounded to second decimal point and sorted from beginning of the year to the end of the year. The percentage change column will be populated from the second month forward and can be calculated as the following formula. Okay, so we are given an SF transactions table. It is an granular table of raw daily transaction logs. It has ID created at on which date the transaction happened, the value of the transaction, and purchase ID of the transaction. In the output, here is our expected output. We need to clean corporate. We need a clean corporate growth report showing month over month revenue percentage changes rounded to the two decimal places, sorted chronologically. It has two columns, year, month, and revenue difference percentage. Okay, so I will first start by writing the code. So first I will write the pseudo code for this. First, format the daily dates into a YYYMM month bucket and group by to calculate the total monthly revenue. Second, use the lag window function. Use the lag window function to pull the month revenue. Previous month's previous month's revenue onto the exact same row as the current month. Third, apply the month over month math formula. Month over month math formula. Current minus previous. Current minus previous upon previous into 100. Finally, cast the denominator to numeric to rounding off prevent rounding errors. Wrap the final number in a round function and sort chronologically. So I will start by writing the code with monthly revenue CTE as select to char to character to select character to char created at in the format as year month some value as revenue current month revenue from SF underscore transactions group by to character created at by we make our second CT table revenue CTE logged revenue CTE as select year month comma current month then I write current month revenue lag current month revenue over current month revenue over current month revenue over order by year month as previous month revenue from monthly revenue CTE monthly revenue CTE. Now I will get outside the CTE table, select year month, round current month revenue minus previous month revenue upon previous month revenue numeric colon numeric into 100 into 100 comma 2 as revenue difference percentage as revenue difference percentage from logged revenue CTE. Order by year month. Order by year month. Okay, so this is a $1,000,000 interview trap question. Now a lot of intermediate developers make a massive mistake here. They try to use window function like sum over partition by month to calculate monthly revenue. A window function leaves your table at the individual transaction level. If you don't collapse your rows using traditional group by, your lag function will completely fail because it will look at the previous transaction instead of previous month. Always flatten your data before doing period over period calculations. So we start with our first CTE, monthly revenue CTE. We use two-char created at year month to strip away daily timestamps and extract a clean year month format. Then we use a standard sum value paired with group by. This completely collapses our transaction data, leaving us with exactly one single row per month containing its grand total revenue. And now our second CTE. Now that our data is perfectly flat, we build our second CTE. We use the lag window function, lag current month revenue over order by year month. Because our table now has exactly one row per month, sorted chronologically, lag successfully reaches into the previous row and grabs the prior month's total revenue, placing it right next to our current month's revenue. Finally, we step into our main select block and apply month on month formula. Current minus previous upon previous into 100. In PostgreSQL, always cast your denominator using numeric. To avoid integer truncation error, we wrap the entire calculation inside the round function to satisfy the product manager's requirement. Sort chronologically using order by year month and hit execute. Error, syntax error at the line 25. Our solution is accepted. So we flawlessly passed this question. Now let's move to our question number 12. Okay, let's move to question number 12 of our SQL interview question series. So question number 12 is average salaries. We have to compare each employee's salary with average salary of the corresponding department and then output our department first name salary of the employee along with the average salary of that department. We are given an employee table. It has following columns: ID, first name, last name. So basically, it is the list of individual employees, their department, and their exact salary. Then we need, here is the expected output. We need a report comparing each person's salary directly against their department's overall average salary, sitting side by side on the same row. Okay. So first I will start by writing the pseudo code. First select select the individual worker columns. Select the individual worker columns, department, first name and salary. So we keep every single employee row intact. Second, calculate the department wide average using the average function as a window function as a window function. Third, use partition by department to create isolated mathematical bundles for each department. Finally, strictly omit the order by clause inside the window function to prevent the SQL from calculating a row by row running average. Okay, I will start by writing the code. Select department, select department, first name, salary, average salary over partition by department as average salary from employee. Okay, before we had a list of individual employees and their departments and their exact salaries. Then we need a report comparing each person's salary directly against their department's overall average salary sitting side by side on the same row. Now, a lot of candidates know that they need to use window function here because we cannot use a group by without losing the individual employee names. But here is where 80% of the people mess up. They write average salary over partition by department group by ID. Do not add an order by here. The moment you add an order by to an aggregate window function, SQL stop looking at the whole department. Instead, it computes a running row by row moving average to get the true fixed department average across all the rows. You must leave the order by out completely. So the implementation is incredibly clear. We select our we select our row columns, department, first name and salary. Then we set up our window metric, average salary over partition by department. By partition by department, SQL creates an temporary mathematical boundary around each department like audit or management. It calculates the grand average for that bucket and perfectly broadcasts that single number next to the every single employee in that department. We hit execute and we hit execute. Idea our solution is accepted. So let's move to our next question. Question number 13. So let's move to our question number 13. Our question number 13 is risky projects. So first I will read out the question for you. You are given a set of projects and employee data. Each project has a name, a budget, and a specific duration, while each employee has an annual salary and may be assigned to one or more projects for particular periods. The ask is to identify which projects are over budget. A project is considered over budget if the prorated cost of all the employees assigned to it exceeds the project's budget. To solve this, you must prorate each employee's annual salary based on the exact period they work on a given project relative to a full year. For example, if an employee works on a 6-month project, only half of their annual salary should be attributed to that project. Sum these prorated salary amounts for all the employees assigned to the projects and compare the total with the project's budget. Your output be a list of should be a list of over budget projects where each entry includes the project's name, its budget, and total prorated employee expenses for that project. The total expense should be rounded up to the nearest dollar. Assume all years have 365 days and disregard leap years. So first I will look all the three tables which is provided to us. First table which is provided to us is projects table. It has project ID, title, budget, start date and end date. Okay. Second table is employee projects. It has employee ID to their assigned project ID. Third table is employee table. It has employees ID, first name, last name and the salary. So here is our expected output. We are expected to give the title, budget and the prorated employee expense. So first I will write the pseudocode for this problem. First, build a three table join connecting the projects table to employee table using the emp underscore projects bridge table. Second, calculate the project duration, end date minus start date, and the employee's daily rate salary upon 365. Third, multiply multiply the daily rate by the the duration and sum this up for all employees grouped by the project. Finally, round the total cost up using CEIL and filter the results in a having clause to only show projects where this total cost is greater than the budget. Okay, I will start by writing the code. Select p dot title, comma p dot budget, comma ceiling of sum of e dot salary numeric, upon 365 into p dot end date minus p dot start date as prorated employee expense. Prorated employee expense from LinkedIn projects as P. Join LinkedIn EMP projects as EP on p.id. p.id equals to ep.project id is equals to ep dot equals to ep dot project id. Join LinkedIn employees e LinkedIn employees as e on ep.empid equals to e dot id group by p dot title comma p dot budget having ceiling sum of e dot salary upon 365 into start a greater than p dot budget. So first I will write this code. There is an error. Line number 10. अच्छा LinkedIn underscore projects. Okay, I hope this code is fine. We have no syntax error here. So before we have list of corporate budgets with fixed budgets. Before we have list of corporate projects with fixed budgets. A list of employee with annual salaries and a bridge table tracking who worked on what. Okay. We need to we need a strict risk management report that only outputs the projects that went over the budget after calculating the exact prorated daily cost for. The biggest trap here is the architecture. Beginners will stare at the projects table and the employees table and panic because they don't share any columns. You cannot join them directly. You must recognize many to many pattern. Use project employees projects table as a bridge. You join the projects to the bridge and bridge to the employee. Okay, the three table bridge join. Let's start. Let's build the architecture first. We start from LinkedIn projects P. We start from LinkedIn projects as P. We join we join our bridge table LinkedIn employee projects as EP. Matching the project's IDs immediately after, we add a second join to the LinkedIn employees as E, matching the employee IDs. We have successfully linked our workers to their specifically projects. Now we group our data by the project title and budget so we can do our math. Here is the exact formula. We take the salary numeric upon 365 to get the worker's exact daily rate. We multiply that by the end date minus start date to get the total number of days the project ran. Finally, we wrap all that inside a sum function. Inside a sum function, this perfectly aggregates the fractional cost of every single employee for the specific project. Okay. The prompt explicitly asks us to round the expenses up to the nearest dollar. In PostgreSQL, the ceiling function does exactly this. We wrap our entire sum calculation in ceiling function. Lastly, we don't want to see all the projects, only the risky ones, because we are filtering based on an aggregate sum. We cannot use a where clause. We must drop down because we are filtering based on an aggregate sum. We cannot use a where clause. We must drop down. We must drop down to a having clause where having ceiling the greater than budget. We execute this query and yeah, we pass with the flying colors. So let us move to our question number 14. It is finding purchases. So let's move to our question number 14. Our question number 14 is finding purchases. It was uh, it is a medium level question. It was asked by Amazon. So first I will read out the question for you. So here is our question number 14. Finding purchases. Identify returning active users. Identify returning active users by finding users who made a repeat purchase within 7 days or less for their previous transaction, including same day purchases. Output a list of these user ID. Okay, so uh, here is the input table which we are given. We are given an Amazon transactions table. It has 5 columns: ID, user ID, item created at, and revenue. So it is a standard Amazon transaction log table, and our expected output is this. We need a unique list of returning users who made a repeat purchase within a month or less of their immediately preceding purchase. Okay. So first I will write the pseudo code. Okay. First first look at each user's history by partitioning by user ID and sorting chronologically. Second, use the lag use the lag window function to pull the immediately immediately preceding preceding purchase date purchase date onto the current row. Third, sub- subtract the previous date from the current date to find the time gap between consecutive consecutive purchases. Finally, filter for gaps between one finally finally filter filter for gaps between 1 and 7 days to catch active users while same day excluding same day transactions and deduplicate using distinct using distinct. Okay, first I will write the code for this, then I will explain it to you. First I will create a consecutive purchases CTE with purchases as select user ID created at lag created at lag created at over partition by user ID over partition by user ID order by created at as previous created at from Amazon transactions select distinct distinct user ID from consecutive purchases where created at minus previous created at between 1 and 7. So here is our code. I will explain you this again. Alright, question number 14 is beautiful mind-bending problem because it looks identical to the problem we solved earlier, but with a one critical word change. Before we had a standard Amazon transaction log table. We need Now we need to create a list of returning users who made a purchase within a week or less or their immediately preceding purchase of their immediately preceding purchase. Okay, if you are following this masterclass series, you might remember the question number 8 where we had to strictly measure the user's first purchase. In that question, using lead or lag was a massive trap. But look at the wording here within 7 days of their previous transaction. That one word changes the entire architecture. Now, minimum function is a trap. The window function is our savior. We need to track the gap between any two back to back purchases. Okay, we start now. I will explain you the code. We start by setting up a CTE called consecutive purchases. Inside we pull the user ID and created at. Then we deploy our time function lag created at over partition by user ID order by created at. This separates the data by users orders by their shopping history from oldest to newest and reaches one row backward to grab the date of their prior transaction. Now we step out of the CTE because created at and previous created at are sitting on the exact same row. We perform the basic PostgreSQL date math in our where clause, where created at minus previous created at subtracting two dates returns an integer representing the days between them. The prompt explicitly commands us to execute same day purchases. To exclude, the prompt explicitly commands us to exclude same day purchases. If a person buys two things on Tuesday, the difference is 0. By writing between 1 and 7, we mathematically filter out the same day 0 day gaps while capturing anything up to a week. We seal it with a select distinct user ID to prevent users who do this multiple times from cluttering our output, and we have a perfect passing query. Run this code on Stratascratch. Let's run this code on Stratascratch. You see, our output is accepted. Okay, so let us move to our question number 7. So our question number 7 is ranking most active guests. So here is our question number 15. So first I will read the question for you. Here is our question number 15. First I will read out the question for you. Ranking most active guests. Identify the most engaged guest by ranking them according to their overall messaging activity. The most active guest, meaning the one who has exchanged the most messages with host, should have the highest rank. If two or more guests have the same number of messages, they should have the same rank. Importantly, the ranking shouldn't skip any number, even if many guests share the same rank. Present your results in a clean format, showing the rank, guest identifier, and total number of messages for each guest, ordered by the most to least active. Okay, so let's start. We are given an contact city table. It has things like guest ID, host, listing, etc. etc. It is a raw communication log showing every single individual message exchange between guests and the host. Okay, here is the expected output. We need a clean deduplicated leaderboard showing rank, the guest ID, and their total aggregated message count, ordered from most active to least active. So first I will start by writing the pseudocode. First, use group by use group by ID guest to collapse all multiple messaging interactions into exactly exactly one row per unique guest. Second, calculate calculate their overall activity by applying the sum calculate the overall activity by applying the sum n messages by calculating the sum n messages aggregation. Third, use the dense rank use the dense rank use the dense rank window function to rank them from the highest okay from rank the highest message count to the lowest. Finally, ensure the ranks, ensure the ranks never skip a number by utilizing the dense rank rather than the standard rank function. Okay, I will start by writing the code first. So we have to select select dense rank select dense rank over sum of order by sum. Then I sum all the messages that they have sent. Sum n underscore messages in descending order as ranking id guessed sum of uh, sum of all the messages sum of n messages as sum n messages from Airbnb underscore contacts group by id underscore guest. Okay, first I will explain you this code. So we have to we have before we have in raw communication log showing every single individual message exchange between the guest and the hosts. Okay, after we need a clean deduplicated leaderboard showing the rank, guest id and total aggregated message count ordered from most active to least active. Okay, I will explain you this code. When an interviewer tells you to calculate a total sum and rank the user when a interviewer tells you to calculate a total sum and rank the users at the same time. Intermediate developers often freak out and build three different nested CTEs because they are trying to use window functions for both tasks. But here is a pro tip that will make you like a senior engineer on a whiteboard. You can actually nest a regular aggregate function inside a window function. By using a traditional group by, we can collapse our rows first, then rank those collapsed groups into a single step. Okay, we start at the bottom of our query, group by guest ID. This is our foundation. It ensures that a guest has logged 100 different messages across 10 different trips. All of those rows are immediately squashed into one unique row for that guest. To find their total activity, we simply write sum of n messages as sum n messages. Now, how do we rank them? The prompt gives us a very strict constraint. If two or more guests have the same number of messages, they should have the same rank, and the ranking shouldn't skip any numbers. This is a universal bad signal for dense rank. If we use standard rank, the two people tied for the first place, the next person would rank third. Dense rank guarantees a tight continuous leaderboard. 1, 2, 3 like this. We write dense rank over order by sum of n messages in descending order as ranking. Notice how we literally placed our sum function right inside the window ordering clause. SQL will execute group by sum first, then instantly rank the resulting sums. We run the query and it's a beautiful single statement. We run the query and it's a beautiful single statement, green check mark. So our solution is accepted. In the output we have received the ranking of the guest IDs and total number of messages that they have sent. So yeah, our solution is accepted. So let's move to our question number 16. So let's move to our question number 16, which is number of units per nationality. I will write delete my practice code. So first I will read out the question for you. Number of units per nationality. Write a query that returns how many different apartment type units counted by distinct unit ID are owned by people under 30, grouped by nationality. Sort the results by a number of apartments in descending order. We are given two tables. The first table is Airbnb host. It has host ID, nationality, gender, and age. Okay. And our next table is Airbnb units. It has host ID, unit type, room type, country, etc. And we have to output this. We have to output nationality and apartment counts of that nationality. Okay. We have two separate table. One is an HR style table of our hosts and their personal demographics. The other is a property log of physical units they own. Okay. We need a targeted marketing report showing exactly how many unique apartment styles are owned by young hosts under 30, grouped by their nationality and sorted from highest to lowest. Okay, first I will start by writing the pseudo code. First, first build a bridge. First build a what's the time? 30 this. First build a bridge between our hosts table and units table using this shared host ID so we can see which person owns which property, owns which property. Second, apply two strict filters in the where clause. In the where clause, the host's age must be strictly under 30 and the unit type must be exactly apartment. Okay. Third, group group the remaining data remaining first group the remaining data by the host's nationality. Finally count finally count the unique number of apartments using count distinct unit ID and sort the final leaderboard sort the BOARD final leaderboard in descending order. Okay, I will write the solution first. Select h dot nationality count distinct distinct u dot unit ID as apartment count from Airbnb hosts as h inner join Airbnb units as u on h dot host id equals to u dot host id where h dot age is less than 30 and joined by host id and age of the host must be less than 30 and unit type must be apartment and u dot unit type equals to apartment group by h dot nationality h dot group by nationality order by apartment count in descending order by apartment count in descending order. Okay, I will explain you this code now. So we are given two separate tables. One is an HR style table of our host and their personal demographics. And second is a property log of the physical units that they own. We need to create a targeted marketing report showing exactly how many apartment style units are owned by people under 30 and grouped by their nationality and sorted from highest to lowest. Okay. A lot of beginners will try to do this with nested subqueries, filtering the host first and then trying to join. You don't need to overcomplicate it. You can do all your joining filtering in one clean sweep. However, the one massive trap is the aggregation. The prompt strictly asks us to different asked us for different apartment type units. If you write count of unit IDs, a single apartment get logged twice. for maintenance issue and your count will inflate. You can use count distinct unit ID to protect integrity of your math. Okay. We start by joining our tables. We pull our Airbnb host as H and inner join to to connect Airbnb units as U on their shared host ID. Instantly, we drop down to our where clause and apply our two strict business rules. Age is less than 30 and unit type is apartment. Grouping. Now that our data set is perfectly filtered down to just young apartment owners, we need to bundle them. We use group by nationality to create our geographic buckets. Finally, we hop to our select statement. We grab the nationality from we grab the nationality column and we execute our bulletproof aggregator. Count distinct unit ID as apartment count to satisfy the final requirement of the prompt. To drop a to drop to the very bottom, we drop to the very bottom and add order by apartment count in descending order. Okay, we run our query. Syntax error. Line number 17. We run our query and we get a beautiful green check mark and our solution is accepted. So let's move to our question number 17 now, which is let's move to our question number 17. Our question number 17 is number of units per nationality. No, it was overhead. Next question is find the number of inceptions for each risk category by inception type. Okay. So first I will read out the question for you. Our question is find the number of inceptions for each risk category by inception type. Find the number of inceptions that resulted in each category per each inception type. Inspection type. Find the number of inspections that resulted in each risk category for each inspection type. Consider the result with no risk category value belongs to a separate category. Output the result with the corresponding inspection type, the corresponding total number of inspections per that type. The output should be pivoted, meaning that each risk category and the total number should be a separate column. Order the result based on the number of inspections and number of inspection per inspection type in descending order. Okay, two we are given a table which is restaurant health violations. It has their business ID, business name, address, city, state, postal code, etc. etc. And one important row is inspection type and risk category. Okay. We have to output inspection type. We have to output inspection type and total no risk restaurants in it and low risk results, medium risk, high risk, and finally total risk inspections. Okay. So before we had a vertical column of health inspection logs where the risk category is buried in a single column. Okay. After we need to flip the data horizontally into a beautiful dashboard ready summary table where each inspection type has its own row and every risk category gets its own dedicated column. First, I will start by writing the pseudocode for this. Okay. First, group the dataset. Group the dataset by the inspection type. So each type has its own single row. Second, use conditional aggregation. Use conditional aggregation sum. Case when case when case when to pivot the data, creating a separate bucket for low, moderate, and high risks. Third, explicitly handle the missing data by building a specific case when bucket for when risk underscore category is null. Finally, use count star to calculate to calculate the grand total of ins- inspections for that group and sort the output by this total in descending order. Okay, I will start by writing the code first, then I will explain it to you later. Select inspection type, inspection underscore type, comma, some case when risk category equals when case when risk category is null, then 1, else 0, and as no risk results. Case when risk category equals to low risk, then 1, else 0, and as low risk results. Case when risk category is moderate risk, then 1, else 0, as medium risk results. Case when risk category equals to high risk, equals to high risk, then 1, else 0, and as high risk results, then count star as total violations from SF restaurant health violations group by inspection type, order by total inspection in descending order. Okay, I will explain you this code now. Before we had a vertical list of Before we had a vertical list of health inspection logs, various categories buried in a single column. Various categories buried in a single column. We need to flip the data horizontally in a beautiful dashboard-ready summary table, where each inspection type has its own row. Every risk category gets its own dedicated column. Okay, let's start with the logic. When an interviewer asks you to turn rows into columns, they are testing if you know conditional aggregation. We can't just use a basic count because that counts everything. We need to count conditionally by wrapping a case when statement directly inside our sum function. Okay. We start by grouping our data by inspection type. Now to build our columns, we use our conditional logic. Some case when risk category equals to low risk, then 1 else 0 and this mathematically acts as target filter. If row is low risk, it assigns a 1. If it's anything else, it assigns a 0. The sum function then adds up all the ones, effectively counting only the low only the low risk inspections. The, the prompt throws a massive curveball, considering the records with no risk category value belongs to a separate category. If you just filter for the test, text strings, you will drop data. We must explicitly build a bucket for missing values using some case when the risk category is null, then 1, else 0, and finally, we need a grand total column. Many beginners will write a massive CT and physically add the four columns together: no risk, low risk, plus medium, plus high. We don't need to do that. Just drop a count star as total inspections. It completely bypasses the case statements and just counts every single row inside the inspection type bundle. We order our final output by total inspection in descending order. We hit run. Okay, we have an column inspections table does not exist. Total total inspections does not exist. Total violations क्यों लिख दिया? Order by इस total violations नहीं है, total inspections. We check our solution and yeah, it is expected. We pass with flying colors. So let's move to our next question number 18. Let's move to our question number 18. It is calculate. First I will delete my practice what I have done before. So our question number 18 is calculate Samantha's and Lisa's total sales revenue. Okay. It is an easy level question where we have to find what is the total sales revenue of Samantha and Lisa. We are given a sales performance table. It has salesperson, widget sales, and revenue what they have made. Okay, we have to calculate total revenue of Samantha and Lisa. I will write the pseudocode first. First, filter. First, filter the data set using the where clause. to only include the rows belonging to the targets. Second, use the in operator to efficiently check for multiple multiple names, Samantha and Lisa. Samantha, Lisa, Lisa, without writing multiple or statements. Finally, apply a global sum to the sales revenue column of this filtered data and alias it as total revenue. I will start by writing the code then. Select sum of sales revenue as total revenue from sales performance where sales person in Samantha, Lisa, okay. So before we are given a massive tables of all the salesperson and their individual transactions. Okay, we are given a massive a table of all our sales people and their individual transactions. We need a single cell containing a single number, the combined total revenue of just Samantha and Lisa. Okay, so a lot of people who just learn conditional aggregation will try to solve this query by CTE to find Samantha's total, then Lisa's total, then adding them together. You are doing too much work. Since the prompt doesn't ask us to keep our total separate, we can just filter the raw data first, then sum everything at once. We keep the architecture incredibly simple. We drop down to our where clause and write where salesperson in Samantha, Lisa. The in operator acts as a superpowered or statement, instantly stripping away every other employee from our dataset. Now that our table only contains Samantha and Lisa's sales, we jump to our select line, hit the entire column with a sum sales revenue and alias it as total revenue. Three lines of code, mathematically perfect and highly optimized. I will check the solution and our solution has been accepted. So let's move to our next question, which is question number 19. Find the percentage of shippable orders. Let's move to our question number 19, which is find the percentage shippable orders. Okay, first I will read the question for you. Find the percentage of shippable order. Consider an order shippable if customer's address is known. Okay, we are given two tables. First table is of orders. It has customer ID, order date, order details, and total order count, total order cost, and the customer table. It has the details of the customers, and our expected output is this percentage shippable. Okay, orders. First, I will write the pseudo code. First, establish the order orders table as our base as our base, and left join the customer and left join the customers table to ensure we do not lose any orders, even if the customer profile is missing, even if the customer customer profile is missing. Second, leverage the fact that column names automatically ignores null values. We will use count c dot address to get the number of shippable orders, and count o dot id to get absolute total number of orders. Third, divide the shippable orders by the total orders. Finally, cast the denominator to numeric to prevent PostgreSQL PostgreSQL from rounding down to zero. Multiply by 100 to get the percentage and alias it. I will start by writing the code first, then I will explain it to you. Select count of c dot address, count of c dot address upon count of o dot id numeric. into 100 as percent shippable from orders as O left join customers as C on O dot customer ID O dot customer ID equals to C dot ID. So alright, we are given a primary log of our orders and separate database of our customers that contains shipping orders that contains shipping addresses. We need a single cell output. We need a single cell outputting the exact percentage of orders that are ready to be shipped, meaning they actually have valid addresses attached to them. Okay, here, okay, the interview trap. There are two massive traps here. First, if you use standard inner join, you will drop any order that doesn't have a matching customer profile. This artificially shrinks your total order count and ruins your percentage. You must use left join from orders table. Second, if you just divide the whole numbers in PostgreSQL, it rounds the decimal down to 0. You must cast your math to a numeric type. Okay, let's write the code. Let's build this in a one clean sweep. We start from orders as O and left join customers as C on customer ID equals to C.ID. This guarantees our denominator remains untouched. Now we jump straight to our select line to do our math. Here is a pro tip. Count column ignores null values. So count C.addresses. Count column ignores null values. Okay. So count C.addresses. Count C.addresses perfectly calculates the shippable orders. We divide it by count of ID. Okay. Which is our absolute total orders. To prevent division rounding trap, we attach numeric to our denominator. We wrap the entire equation in parentheses, multiply by 100, and alias it as percentage shippable. One on one single block of code, mathematically flawless. Let's run it. Yeah, our code has been accepted, so it gives the percentage shippable orders as an output, which is 41.94. So let's move to our next question, which is our question number 20. Meta Facebook matching users pairs. So let's open it. Okay. Okay, here is our question number 20. Meta Facebook matching users pairs. Okay. Find the matching pairs of Meta employees such that they both are of same nation, different age, same gender, and different seniority level. Output ID by paired employees. Okay, we are given an Facebook employees or यार internet नहीं है. So let us preview our table. It is a Facebook employees table. It has ID, location, age, and gender of the employees. It is basically an HR table. So we are given this Facebook employee tables, and we have to output two columns of employees which have same nation, different age, same gender, and are at different seniority levels. Okay. First, I will start by writing the pseudo code First, set up a self set up a self join by calling the Facebook employees table twice, giving them two distinct aliases, E1 and E2. E1 and E2. Second, build the on clause using the exact using exact business rules. Using exact business rules. Match the location, gender, but ensure age and is senior are strictly not equal. Third, mathematically eliminate 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 mirrored duplicates duplicate pairs by facing e1.id less than e2.id. Finally, output output the id from table 1 and the id from table 2 as your perfectly matched pairs. Okay, first I will write the code. Select e1 dot id as employee underscore 1 employee underscore 1 e2 dot id as e2 dot id as employee underscore 2 comma from Facebook employees as e1 join Facebook employees as e2 on e1 dot location equals to e2 dot equals to e2 dot location and e1 dot gender equals to e2 dot gender and e1 dot age e1 dot age equals to is not equals to is not equals to e2 dot age and e1 dot is senior is not equals to e2 dot is senior and e1 dot id less than e2 dot id. Okay, first I will explain you the pseudocode. We are given a single table of employees, which has their location, demographic, and seniorities. After we need a strict pairing system that matches two employees side by side if they meet a very specific set of identical and contrasting criteria. When beginners are told to compare data within table, they often panic and try to use union all or crazy subqueries. But union stacks data vertically. The only way to do this is using a self join, literally joining the table to an exact clone of itself. So let's start building the architecture. We write from Facebook employees as E1 joined Facebook employees as E2. We now have a left table and right table. Now we translate the prompts checklist directly into our own clause. It is location and gender must be same and age and seniority must be different. But here is a massive senior level trap. If employee 1 matches with employee 5, SQL will also print a matching row of employee 5 to employee 1 to destroy our mirrored duplicates. We add one final condition e1.id is less than e2.id. This forces the smaller id to always be the first column and mathematically guaranteeing each pair is only generated once. We select our two IDs, hit run. We don't have the internet. Wait. So let me run my code. I will check my solution. Okay, there is an error. Syntax error on line number 9 from as E1. Okay, we have an syntax error from Facebook employees as E1. Okay, what's the error, man? From Facebook underscore employees on E1.id from Facebook employees. Acha, we don't want a comma here. Let me run my code and I will check the solution. Yeah, our solution is accepted. So question number 20 is over. So no, output is still not the same. Acha, they wanted the both. Okay, they want both the pairs. So I will delete this condition. Now I will check solution. Our solution has been accepted. Now let's move to our question number 21, which is this matching similar hosts and guests. Okay, it is our question number 21. So I will first read out the question for you. So find the matching hosts and guests pairs in a way that both are of same gender and nationality. Output the host ID and the guest ID of matched pair. We are given two tables. First is Airbnb hosts. It has host ID, nationality, gender, and age. And second is Airbnb guests, where we are given guest ID, nationality, gender, and age. Okay. And what is our expected output? We have to give pairs of matching hosts and guests in a way that both of them have same gender and nationality. Okay, first I will start by writing the pseudo code for this. Let's uh, directly. So first, let me start by writing the pseudo code for this. Okay. First, set up a standard inner join. Standard inner join between the Airbnb underscore hosts and Airbnb guests table. Second, define the matching criteria in the on clause by equating both the gender and the nationality columns using an AND operator. Finally, select the specific ID columns from each table and apply distinct to guarantee a clean deduplicated list of pairs. List of pairs. A clean deduplicated list of pairs. Okay, I will write the code now. Select distinct h dot host id comma g dot guest id g.guest id from Airbnb underscore hosts as h inner join Airbnb guests as g on h dot gender equals to g dot gender and h dot nationality equals to g dot nationality. Okay, so all right, we have a two separate HR style databases, one logging our Airbnb hosts and one logging our Airbnb guests. Okay, we need a clean matching system that outputs pairs of hosts and guests who share the exact same gender and nationality. Okay, if you just came for solving complex self join, your brain is going to try to overcomplicate this. You must start worrying about mirrored duplicates or solving less than complex less than logic. Don't fall for it because we have two entirely distinct table. We don't have to worry about a host matching with themselves. We can rely on a beautiful foundational inner join. The architecture here is incredibly clean. We write from Airbnb hosts as H, connect it with an inner join Airbnb guests as G. The magic happens right here in the on clause. SQL allows you to join tables on multiple columns simultaneously. We just write on h dot gender equals to g dot equals to g dot gender and h dot nationality equals to g dot nationality. This forces the database to find inter, to find exact intersecting matches across both data points. We jump to our select line, grab h dot host id and g dot guest id and throw a distinct keyword at the front just to protect our output from any weird data entry duplicates in the raw log. Hit execute and we have another mathematically perfect hit enter. We have our mathematically perfect green check mark. So we have solved this question as well. So let's move to our next question, which is our question number 22, I guess. Yeah, which is our question number 22, income by title and gender. So first I will read the question. Okay, it is a medium level question. So I will first start by reading our question, income by title and gender. So find the average total compensation based on employee titles and gender. Total compensation is calculated by adding both the salary and bonus of each employee. However, not every employee receives a bonus, so disregard employees with bonuses in your calculation. Employee can receive one or more than one bonuses. Output the employee ID, gender, and also the average total compensation. So we are given an employee and bonus table. Employee table is an HR table which has ID, first name, last name, age, sex, and other details like department, manager ID, etc. Salary as well. And we have another table called SF bonuses. It is a simple two column table which has two columns like worker reference ID and bonus. Okay. So here is our expected output. We have to give employee title, age and their average compensation. First I will start by writing the pseudo code. Okay. First build ACT to pre-aggregate to pre-aggregate the SF bonus table group by worker reference ID and sum their bonuses. So every employee only has one single row containing containing their total bonus amount. Total bonus amount Second, step outside the CTE and inner join the SF underscore employee table to our newly flattened bonus table. The inner join naturally filters out anyone who didn't receive a bonus. Third group the main query by employee title and sex to create our final output buckets. Finally, calculate the total compensation by adding the base salary to the aggregated total bonus and wrap that equation in an average function. Okay, I will first I will write the code, then I will explain it to you. With pre-aggregated bonuses as select worker reference ID, sum of bonus as total individual bonus from SF bonus group by worker reference ID. Then I will step outside the CT, then I will write my main query. Select e dot employee title, comma, e dot sex, comma, average of e dot salary plus b dot total individual bonus as average compensation from SF employee as inner join pre-aggregated bonuses as B on E dot ID equals to B dot worker reference ID. Okay. Group by E dot employee title, e dot sex. I will run my code. It looks fine. I will explain you the code now. Okay. Before we had an employee table with their base salaries and a separate bonus table tracking every individual bonus payout. We need a clean summary report executing average total compensation broken down by job title, gender, and explicitly excluding anyone who didn't get a bonus. So the biggest trap in data analytics is one to many join. Okay. The prompt explicitly warns us that an employee can receive multiple bonuses. If you just join these table directly, the employee's base salary row will duplicate for every bonuses they received. If they if they got three bonuses, SQL will think they received bonus salary three three separate times. You will inflate your company's compensation math by millions of dollars. We must pre-aggregate the bonus table first. We start by protecting our math. We build a CT we build a CT called pre-aggregated bonuses inside group by worker reference ID and some bonuses. This perfectly flattens the table. If an employee had 5 bonuses, they are now smashed into one single row with their grand total bonus. Now we drop our main query. We select from employee and inner join into our CT. The inner join is brilliant because it automatically acts as a filter. If an employee doesn't exist in our bonus CT, the join drops them entirely, satisfying the prompt's requirement. Finally, we group by employee title and sex to find final number. We add their single base salary to their newly calculated single total bonus and wrap it up in an average and execute. And we check our solution. Our solution has been accepted. So let's move to our next question. So guys, I am back. Let's move to our question number 23, which is top cool votes. Okay. First I will read out the question for you. Find the review text that received highest number of cool votes. Output the business name along with the review text with the highest number of cool votes. This is our reviews table and this is our expected output. We have to find the review text which received the highest number of cool votes. First I will start by writing the pseudocode for the okay for this question. First build a standalone subquery that scans the entire table to find the absolute highest number of cool votes using MaxCool. Second, build the main query to select the business name and review text. Third, use a where clause to filter the main dataset, ensuring it only outputs rows where the cool vote count perfectly matches the maximum number found in our subquery. Now I will start by writing the code. Select business name, review text, review text from Yelp reviews, where cool equals to select maximum of cool from Yelp reviews. When I will check my solution, it has been accepted. Now I will explain you the code again. So alright, we have a massive data set of Yelp reviews, including how many cool votes each review received. We need to output the business name along with the review text for whichever review received the highest number of cool votes. When beginners hear the word highest or top, their muscle memory instantly types order by cool descending order limit equals to 1. In the real world, data has ties. If both reviews, if two reviews both receive 10,000 votes, limit 1 will randomly delete one of them from your report. You will lose critical data. We have to architect a solution that accommodates ties for the first place. To guarantee we catch each and every single top review, we use some query. We start by writing our standard select business name review text from Yelp reviews. Now we drop into our where clause. Instead of hard coding our number, we set where cool equals to. Then open a set of parentheses. Inside those parentheses, we write a subquery. Select max cool from Yelp reviews. Maximum vote is say 500, and secretly replaces our subquery with that number. Then the main query simply returns every single row where the cool count is exactly 500. It dynamically adapts with the data and perfectly captures all ties, giving us the flawless green check mark. Let's move to our question number 24. Our question number 24 is reviews of categories. Okay, it is a medium level question. First, I will read out the question for you. Calculate the number of reviews for each business category. Output the category along with the number of reviews. along with the total number of reviews. Order by total reviews in descending order. We have a Yelp reviews. We have a Yelp reviews table, and it has the columns like business ID, name, categories, etc., etc. And here is our expected output. We have two output category along with their review count. Okay, first I will write the pseudocode for you. First, use string to array categories, comma, semicolon to split the messy text string into a structured array based on the semicolon delimiter. Second, wrap that entirely in the honest function. Honest function to explode the array, dropping every individual category onto its own distinct row. onto its own distinct row. Third, group the dataset by this newly created category column. Created category column. Finally, calculate finally calculate the total reviews for each category using some review count and sort the leaderboard in descending order. Leaderboard in descending order. Okay, select honest string to array categories, comma separated by semicolon as category some review count as review underscore cnt from Yelp business group by category, order by review count in descending order. Okay, I will explain you. First I will hit run button. It looks fine. Alright. We have a Yelp database where a business categories are all jammed into a single text string separated by semicolon. We need a clean leaderboard showing every individual category and its combined review count. If you just try to run a group by on categories column, SQL will group by the entire block of text. If it will read restaurant pizzas as one giant category instead of two separate ones. We have to find a way to rip that string apart and force the individual words onto their own rows before we could do our math. To do this, we use a beautiful two-step Postgres combo in our select statement. First, we write string to array categories semicolon. This tells database to scan the text and chop it into a list of every time it hits a semicolon. Second, we wrap the exact statement inside the nest. A nest is the magic. It takes that list and explodes it vertically, generating a band generating a brand new row for every single word. We alias it as new column as category. Now that our data is perfectly separated, the rest of the fundamental SQL. Now that our data is perfectly separated, the rest is fundamental SQL. We add our aggregation, some review count as review CNT. We jump down group by category and finally we organize our output with order by review count in descending order. We hit the run button and our query is accepted. So let's move to our next question, which is question number 24. So our question number 24 is this: top businesses by most reviews. So it is actually our question number 24. So our question number 24 is this: top businesses by most reviews. First I will read out the question for you. I will read the question number 25 now. Find the top 5 businesses with most reviews. Assume that each row has a unique business ID such that the total reviews for each business is listed on each row. Output the business name along with total number of reviews and orders your results by the total and order your results. Find the top 5 businesses with most reviews. Assume that each row has unique business ID such that the total reviews for each business is listed on each row. Output the business ID along with the total number of reviews. Order your results by total reviews in descending order. If there are ties in review counts, businesses with the same number of reviews receive the same rank. Subsequent rank are skipped. Example, if two businesses tie on rank 4, the next business receives rank 6, skipping rank 5. So here is our input table Yelp businesses and our expected output is this. Okay, we have to find top 5 businesses with most reviews. Okay, review count is this. Review count is this, and business's name. And this is the business name. We have to find top 5 businesses with review count. Okay. First, I will write the pseudocode for this. First, set up a CTE to calculate the ranks for every set up a two ranks for every single business. BUSINESS. Second, use the rank window function ordered by review count in descending order to handle ties by skipping ranks accordingly. Third, query the CTE and filter the results using where rank is less than equals to 5 to safely capture the top 5 ranks top 5 ranks including any ties finally keep the final display clean by ordering the review underscore count in descending order. Now I will write the code for you first. Okay. With ranked business with rank businesses as select name review count rank over order by review count in descending order as RNK from Yelp businesses. Then finally select name review count from ranked businesses where rank is less than equals to 5 order by review count in descending order, review underscore count in descending order. I will explain you this code now. Okay. So first setup. So okay, we are given a list of businesses and their review counts in the Yelp businesses table. Then we need to isolate the top 5 businesses with the most reviews while strictly honoring a specific corporate rule for handling ties. 90% of the applicants will read top 5 and immediately and immediately will type order by, review count in descending order and limit 5. In a real interview, that's an automatic fail. Look at the prompt instructions. It explicitly tells that if there is a tie, the next rank should be skipped. That is the database telling you use the rank window function. If you use limit 5, you will hard chop the data and drop the value ties. Okay. Because SQL doesn't allow you to filter window function directly in where clause, we need to build a CTE called ranked businesses. Inside, we select our columns and write our ranking engine rank over order by review count in descending order as RNK. This assigns a 1 to the first place, 2 to the second place, and if there is a tie for the third, both get a 3 and next row skips to 5. Now, we step outside our CTE, write our final query, write our final query. We select name and review count and filter using where RNK equals to 5. This ensures that even if multiple businesses share top spots, they are completely safe from being chopped off. We order the review count in descending order to keep it pristine, and we pass. And if it's and oh, okay, we have not passed the test with rank businesses CTES. Let me check what is the error, and I will come back. Let's move to our question number 26. Question number 26 is this. Find all the possible varieties which occur in either of the WineMag datasets. Okay. So find all the possible varieties that could occur in either of the WineMag datasets. Output unique output unique variety values only. Sort records based on the variety in the ascending order. Okay. We are given two tables, WineMag. Okay. And another table is also there. This is our expected output. We have to output all the types of variety that have occurred in WineMag P underscore P1 and WineMag underscore P2. Okay, first I will write the pseudocode for this. First, select the variety column from the first table wine mag underscore p1. Second, use the union operator to vertically stack the results with the variety column from the second table winemag underscore p2 using union instead of union all automatically guarantees our final list will only contain unique values. Third, apply apply an order by variety in ascending order at the very end of the query to alphabetically sort the combined datasets. Now I will start by writing the code. Select variety from winemag underscore p1 union select variety. Select variety from winemag underscore p2 order by variety in ascending order. Okay. So we are given two separate tables containing wine reviews and both contain a column called wines variety. We need one single alphabetically sorted list of every unique variety that exists across both the tables. When beginners are asked to find unique values across two tables, they often try to select distinct from table 1, select distinct from table 2, and then stack them using union all. This is a massive trap. If malloc in table 1 and malloc in table 2 is in table 2, union all stacks them both and you will end up having duplicates in your final result. You have to let SQL do the heavy lifting for you. The architecture is simple and elegant. We write select variety from mindmap p1. Then we drop and use union operator, not union all, just union. By its definition, union takes two datasets, stacks them vertically, and automatically purges any duplicates across the entire command list. It is a perfectly optimized. It is perfectly optimized for this exact prompt. We finish by writing select variety from binary p2, and at the very bottom of our script, we add order by variety in ascending order. SQL is smart enough to apply this sort to the final merged dataset. Okay, when we hit enter, our solution is accepted. Okay, now let's move to our next question. Okay, next is our question number 26. Wines varieties tasted by Roger Voss. Okay. Find the wine varieties tasted by Roger Voss with a value in the region 1 column of the dataset. Output unique variety names only. We are given a WineMag P2 dataset table, uh, and we have to find out the varieties that were tasted by Roger Voss. Here is the expected output. Okay, taster name is given here. Now I will write the pseudocode for this question first. First, select the variety. First, select the variety column and apply the distinct keyword to ensure we only output unique wine types. Second, set up your where clause to filter for the specific reviewer taster underscore name equals to Roger Voss. Third, use the AND operator to add our second strict condition. Region 1 is not null, is not null, guaranteeing guaranteeing that we drop any rows where the region data is missing. Then I will write the code first. Okay, select distinct variety from WineMag underscore p2 where taster name equals to Roger Voss and region 1 is not null. Okay, we have a massive table of wine reviews, some of which are missing geographic region data. We need a clean, deduplicated list of wine varieties reviewed specifically by Roger Voss, but actually known, only if we actually know which region the wine came from. A lot of beginners will filter the Roger Voss and will submit the enter. But if you do not account for the missing data, your analytics will be flawed. If a stakeholder asks for the wine with the known region and you accidentally include the rows with completely blank region columns, your dashboard is instantly wrong. You must explicitly filter out the voids. We start with our exact output target. Select distinct variety from WineMag V2. The distinct word protects us from outputting the same wine twice. Now we drop into our where clause to apply our double filter. First, taster name equal to Roger Voss, and then we use AND operator and write our missing data shield. Region 1 is not null. In SQL, null means complete absence of data. By saying is not null, we mathematically guarantee that Every single row in our final output contains a physical value in that region column. We hit enter and we hit enter and lock in with another green check mark. Let's move to our question number 28. Question number 28 is this: hour of highest hour of highest hour of highest gas expense. Find the hour of highest gasoline cost. Assume that there is only 1 hour with highest gas cost. We are given Lyft rides table. It has index, weather, hour, distance travel, and gasoline cost. Here is our expected output. We have to output the hour with the highest gas cost. Okay, I will write the pseudocode for this first. First, select the hour. First, select the hour column directly from the Lyft rides table, as we do not need to aggregate or sum any data. Second, sort the raw data set by the gasoline cost column in descending order. To push the single most expensive ride at the very top. Finally, use the limit 1 to chop off the rest of the table, leaving only the hour associated with that maximum cost. Okay, I will write the code first. Okay, select hour from Lyft rides order by gasoline cost in descending order, limit 1. Alright, we had a log of Lyft rides including exactly how much gasoline cost for each specific ride and what hour and what hour the ride took place. We need to output the hour of the day that contained the single most expensive gasoline charge. Okay. When beginners get into a groove, they start throwing sum and group by at the every problem they see. But read the prompt very carefully. It asks for the highest gasoline cost, not the highest total gasoline cost. If you try to group the data by hour and sum it up, you are answering the wrong question and you will fail the test case. Furthermore, the prompt explicitly tells us assume that there is only 1 hour with the highest gas cost. This is the interviewer handling you a golden ticket to use limit 1 operator without without fear of dropping tight data. Okay. The architecture is beautifully minimalistic. We are simply scanning the raw data. We select hour from Lyft rides. Next, we drop down to our order by clause and sort by gasoline cost in descending order. This takes the single most expensive ride and forces it to row 1. Finally, we apply our golden ticket, limit 1. This chops off the millions of the other rides beneath it and cleanly outputs the correct hour. When we check our solution, okay, it is not accepted. Okay, gasoline cost. When we check our solution, it is accepted. Let's move to our next question, which is question number 29. Okay, here is our question number 29. Find all the Lyft rides which happened on rainy days before noon. Find all the rides which happened on rainy days before noon. It is an easy level question. We have an Lyft rides table. It has the weather and hour, and we have this is our expected output. We are expected to give the first 5 rows. Okay, we are expected to give all the rides that happened on rainy days before the noon. Okay, first I will add the pseudocode for this. First, use the select. First, use the select star wildcard to select star wildcard to grab all the columns from the Lyft rides table satisfying the output requirement. Second, set up the where clause to filter the weather column strictly for the text string rainy. Finally, use the and operator to add the time constraint filtering the integer hour column to be strictly less than 12. Strictly less than 12 to capture morning rides only. I will start by writing the code. Select start from Lyft rides where weather equals to rainy and hour is less than 12. Okay, we have a massive table of Lyft rides including the weather conditions and hour of the day the ride took place. We need to output every single detail of those rides, but strictly limit the data to morning rides that happened in the rain. Okay, this is an easy problem, but it contains a classic reading comprehension trap. The prompt says before noon. Noon on a 24-hour clock is 12. If you write hour less than equals to 12, you will accidentally include the ride that happened exactly on 12 p.m. and you will fail the test case. You must use the strict less than operator. Since the prompt wants all the columns, we stay. Since the prompt wants all the columns, we save time by using wildcard. Select star from left rights. Next, we drop into our where clause. Apply our double filter. First, we lock in the weather condition weather equals to rainy. Then, we use the AND operator to enforce our time constraint, hour less than 12. This mathematically guarantees we only capture the morning rides. When we hit run, we got another mathematically perfect green check mark. Let's move to our question number 30. Question number 30 is this: Lyft driver wages. I will read out the question for you first. Okay. Find all the Lyft riders who earn either equal to or less to 30k USD or equals to or more than 70k USD. Okay. We need to find all the Lyft riders who earn less than 30k or more than 70k USD. We are given the Lyft riders table. It has index start date and yearly salary. And here is our expected output. Okay. First, I will start by writing the pseudo code for this. First, write select start to pull all columns and driver details from the Lyft drivers table. Second, set up the filtering criteria in the where clause using the less than or or equal to operator for the lower threshold. Yearly salary is less than equals to 30,000. Third, use the or operator to bridge your criteria, ensuring the database includes records that meet either the low income or the high income threshold. The high income threshold. Finally apply the greater than or equal to operator for the upper threshold. Okay, now let's write the code. Select star from Lyft drivers from the Lyft drivers where yearly salary is less than equals to 30,000 or yearly salary is more than equals to 70,000. We have a registry tracking every single Lyft rider along with their exact yearly earnings. We need a clean report displaying all the details of drivers at the extreme ends of the financial spectrum. Those who make $30,000 or less alongside those pulling in 70,000 or more. This is an easy level problem, but it features the ultimate logical pitfall for many beginner analysts. If you want to type where salary is less than equals to 30,000 and salary greater than equals to 70,000, your query will return absolutely nothing. Why? Because you have created a mathematical impossibility. A driver cannot make 25,000 and 85,000 at the same time. When you are targeting separate, mutually exclusive groups, you must throw out the and operator and use OR to keep our query clean and meet all the details requirement. We start with select star from Lyft riders. Next, we drop into our where clause to catch the lower threshold, yearly salary less than 30,000. Then we deploy our logical bridge, the OR keyword. This tells the system to fetch a row. If it matches the row, the low band or the high band, it will finish the condition of yearly salary greater than 70,000. When we run our script, it runs seamlessly, unifying both the extreme groups into one perfect output. Okay. Now we move to our next question, which is our question number 31. Artist appearance count. I will read out the question for you first. Find out how many times each artist appeared on the Spotify ranking list. On the Spotify ranking list, output the artist name along with the corresponding number of occurrences. Order records by number of occurrences in descending order. We are given an Spotify worldwide daily song ranking table. It has the artist name, their position, track name, streams, URL, stream date, etc. etc. Here is our expected output. We are expected to give how many times each artist have occurred and ordered by number of occurrences in descending order. Okay, let's write the pseudocode first. First, select the artist column from the Spotify ranking dataset. Second, use the count function to tally every single row that artist appears in and strictly alias the column as n occurrences to match the platform's required output. Finally, use a group by artist clause to collapse the dataset, ensuring the counts are calculated individually for each distinct artist. For each distinct artist. Alright, I will write the code now. Select artist, comma, count star as n occurrences from Spotify worldwide daily song ranking. Group by Group by artist. Group by artist. Order by n occurrences in descending order. In descending order. Okay. Before we are given a massive daily ranking log tracking millions of individual streams, artists, and their chart position, we need to clean top-down leaderboard showing exactly how many times each artist appeared anywhere on the list. In the high-pressure interviews, beginners often see Spotify dataset and instantly try to aggregate the wrong metric. They will see the streams or position columns and they will try to run a sum or average function. Stop and read the prompt. It just asks how many times they appeared. That means we need to count the physical rows. Do not over engineer this. Okay, this is a fundamental grouping architecture. We start by querying the artist column. Next, we drop into our aggregation function count star, which simply counts the rows. We use the as keyword to alias it precisely as n occurrences. Before we introduce an aggregation function next to a row column, we must drop down and group the data using group by artist. This ensures our raw counts are calculated independently for each musician rather than the entire dataset. Finally, to create our leaderboard, we attach an order by n occurrences in descending order and we run the script. Okay, and we have a flawless, mathematically sound top artist ranking. Let's move to our question number 32, which is top ranked songs. Okay, first I will read out the question for you. Find the songs that have ranked in the top position. Output the track name, number of times it ranked at the top, and sort your records by the number of times the song was in the top position in descending order. We are given Spotify worldwide daily song ranking table, and here is our expected output. We have to give the track name and how many times it was the in the top position. Okay, for example, this song Bad and Bougie was in the position number 1. Then I hopefully it was one time, not hopefully. Okay, first I will write the pseudocode for this. First, use the select. First, use the select statement to query the track name and use a simple count function aliased as times top 1. Aliased as times top 1 to tally the hits. Second, add a where clause. To filter the raw data for the position equals to 1 equals to 1 before any math happens, instantly isolating top rank tracks. Third, drop down the drop down and use group by track name to compress the data. Running our counts individually for each song. Finally, apply an order by times underscore top 1 in descending order to organize our song leaderboard from highest to lowest. Okay, now I will write the code first. Select track name count star as times underscore top 1 from Spotify worldwide daily song ranking, where position equals to 1 position equals to 1 group by track name order by times top 1 in descending order times top 1 in descending order. Okay, we have a massive daily streaming list tracking where song lands on the global chart in Spotify worldwide daily song ranking table. We need a clean top-down leaderboard showing only the elite tracks that hit the number one spot, along with exactly how many times they dominated the peak position. A common trap when trying to isolate the specific metric within an aggregation is trying to use complex conditional math like sum statement. But remember, in SQL, you can use where clause to filter the dataset before the aggregation engine ever runs. If you filter the data first, you completely eliminate the need for complicated case statements and keep your script lightning fast. When beginners are asked to find three different matrices, they often panic and try to write three separate queries or complex subqueries to force the data together. But you have to remember that how SQL aggregation engine works. If you do not include a group by clause, the SQL assumes you want the global summary and will automatically align you all the maths into a single row. Okay, now I will explain you the code. The architecture is beautifully simple. We just jump straight into the select statement and line up our math. We use minimum of age as lowest age, average age as mean age, and finally max age as highest age. We point this at our Olympics athletes events table. We completely ignore the prompts warning about the duplicates because the hint explicitly tells us that every entry as the separate athlete. Hit run, and our solution is accepted, and all the three matrices are calculated. Okay, so now we move to our next question, which is question number 33. Our question number 33 is this: find all the athletes. So, guys, let's move to our question number 34. Our question number 34 is this. Okay, we have to find all the athletes who were older than 40 years when they won either bronze or silver medals. Find all the athletes who were older than 40 years when they won either bronze or silver medals. Okay, here is our Olympics athletes events table and expected output is this. Okay, all these athletes were older than 40 when they won their bronze or silver medals. Okay, I will write the pseudocode first. First, select what the prompt exactly what the prompt asks for the name column. Second, set up the where clause with strict the strict numerical filter. The strict numerical filter, it is age greater than 40. Third, third, use the and operator combined with the in operator to check check if the medal column matches any value inside our provided list. Inside our provided list, bronze, silver. Select name from Olympic athletes events. where age is greater than 40, age is greater than 40, and medal in bronze or silver, bronze, comma, silver. All right. Our question number 34 from Olympics dataset tests our ability to stack multiple conditions without breaking any logic. So before we have a massive roster of Olympic athletes, their ages and their medal results. After we need a targeted list of names representing only the veteran athletes, specifically those strictly older than 40, but managed to walk away with either silver or bronze medal. Okay. The interview trap. The biggest trap here is how SQL reads add and or statements. If you write where age is greater than 40 and medal equals to bronze or medal equals to silver without parenthesis, the database gets confused. It evaluates the and first and giving you the 40 plus year old bronze winner, but then the or acts independently, giving you every single silver medalist in the history, regardless of the age. You either must wrap or conditions in strict parentheses or use a much cleaner method, the in operator. We start simple. Select name from Olympic athlete series. Next, we drop our where clause for the first condition, age is greater than 40. Then, to safely handle the multiple medal types, we use and medal in bronze or silver. The in operator acts like a clean, built-in list checker. It guarantees that the age constraint applies perfectly to both medal types without any parenthesis confusion. Hit run and you have got another flawless executed query. Okay. Now we move to our question number 35, which is this order details. I will read the question for you first. Order details. Find the order details made by Jill and Eva. Consider the Jill and Eva as the first name of the customers. Output the order date, details, and cost along with the first name. Order records based on the customer ID in ascending order. We are given two tables, customers and orders. Okay, and here is our expected output. We have to give order details made by Jill and Eva only. And here is our expected output. So first I will write the pseudocode for this. First, select the requested columns from both tables from both tables, utilizing clear aliases c dot first name, comma, o dot order date, comma, o dot order. Okay, whatever the details are, order details, order details, comma, o dot total order cost. Second, state your primary table from customers as C. Third, use an inner join to connect to orders as O, matching the the customer's primary key to the foreign key in the orders table on c.id equals to o dot c.id equals to o dot customer id. Fourth, filter for the specific shoppers using where c dot first name in Jill, Eva. Finally, sort the results alphabetically or numerically by the customer ID, order by c.id in ascending order. Okay, now I will write the code first. Okay, select first name, order date, order details, and total order cost. From customers as C, join orders as O, and on okay where C dot first name in Jill, Eva, order by C dot id in ascending order. Okay, before we have a table of customer tables. Before we have a table of customer profiles and a completely separate table mapping out the transactions. We need to unify these tables to reveal. We need to unify these tables to reveal a complete purchase profile. The order details, the order date, details, cost, and specifically for the customers named Jill and Eva, sorted by their account IDs. Okay. The single filter mistake people make while joining the table is seeing an ID column in table A and ID column in the table B and blindly writing on ID A dot ID equals to B dot ID. Stop. An order ID has nothing to do with the customer's ID. To connect a transaction back to the human who made it, you must look for the foreign key column, in this case customer ID. Joining on the wrong keys is the number one cause of completely scrambled data dashboards. Okay, I will explain you the code now. Our architectural blueprint is simple. We select four columns using our short aliases and O. We put from customers as C and run our inner join orders as O. We build the accurate relation bridge by order. We build a accurate relation bridge by writing on c.id equals to o.customer id. This guarantees that Jill's profile aligns with perfectly with the Jill's actual receipts. Next, we filter our specific targets with where first name in Jill and Ava, keeping a sharp eye on the exact capitalization. Finally, we obey the sorting rule by adding order by c.id in ascending order at the very bottom. When we check our solution is accepted and we move to our next question, which is our question number 36. Departments with 5 employees. It is an easy level question. Find out departments with more than or equal to 5 employees. We are given an employees table and we have to output the departments who have 5 or more than 5 employees. First, I will write the pseudo code for this. First, select the department column from the employee table. Second, use a group by department clause to collapse applying to collapse the dataset into distinct departmental clusters. Department clusters. Third, immediately follow the group with a having clause, applying the count function to ensure we only return departments where the total number of employees is greater than or equal to 5. Now I will write the code. Select department from employee group by department having count of id greater than or equal to 5. Greater than or equal to 5. Okay, I will explain you the code now. Alright, we need a strict list. We have a strict list of employees. We have a standard employee directory listing everyone's role and department. After, we need a strict list showing only the names of the departments that are fully staffed with 5 or more people. Okay. The number one trap in this problem is the where clause. When beginners see filter for 5 employees, they instantly type where count of ID is greater than equals to 5. SQL will immediately throw a syntax error and crash. Why? Because the where clause filters raw ungrouped rows. It operates before any math happens. If you fil- if you want to filter a column that has aggregated or counted, you are legally required to use having clause after the grouping phase. Okay, I will explain the code now. The architecture is simple once you know the rule. We start with select departments from employee. Next, we cluster our data so the counting engine knows what to do, group by department. Now that our data is properly grouped into buckets, we can apply our post aggregation filter. We drop down and write having count ID is greater than equals to 5. This scans the this scans the counted buckets and drops any departments that fall short of the threshold. When we hit execute, our query runs flawlessly, and now we move your we are officially okay. Let's move to our question number 37, which is highest target under manager. Question number 37, highest target under manager. Identify the employees working under the manager, manager ID equals to 13, who have achieved the highest target. Return each employee such return each employee return each such employee's first name alongside the target value. The goal is to display the maximum target among all the employees under manager ID 13 and show which employees reached the top value. We are given Salesforce employees table. Here is our expected output. We have to output the employees who have achieved the highest target under the manager 13. I will write these on-screen pseudocode first. First, set up main query to select the first name and target from the Salesforce underscore employees table from the Salesforce underscore employees table. Second, apply the base filter in your where clause to only look at manager underscore id equals to 13. Third, add an and operator to check if their target equals the absolute maximum target. To find this dynamically open a set of parentheses to create a subquery. Inside the parenthesis, write a mini write a mini query that calculates select max target strictly for manager underscore id equals to 13. The database solves this first returning 400 and feeds that number back to the main query to catch all the tiled top performers. Okay, I will write the code now. Select name, comma, target. First name, comma, target. First name, comma, target from Salesforce employees, where manager ID equals to 13. Manager manager ID equals to 13 and target equals to select maximum of target from Salesforce employees, where manager ID equals to 13. Alright, it was a medium level difficulty question. We we have a massive Salesforce directory filled with their teams, managers, and sales target. We need to isolate manager 13's team, find out what the absolute highest sales target was, and output every single employee who hit the exact number. Okay, the interview trap. When beginners are asked to find the highest value, they instantly sort descending and type limit 1. But look at the output. There are 3 employees who all tied up for the top target. If you use limit 1, you will chop 2 of these top performers off the list and immediately fail the interview. When you need to preserve tied data, you must use subquery. We start by writing our main query exactly as we normally would. Select first name, comma target from Salesforce employees, where manager ID equals to 13. Now we need to filter. Now we need to filter for the top target. We write and target equals to. But instead of hard coding a number, we open a set of parentheses. Inside the parentheses, we write our subquery. Select max target from Salesforce, where manager ID goes to 13. The SQL engine acts like it's doing basic algebra. It solves the math inside the parentheses first. It finds the highest target is 400 and seamlessly passes the 400 back to the main query, filtering the anyone who hit the target 400. When we hit run, our we get our code is accepted. Okay, our query is accepted. So let's move to our next question, which is question number 35. Sorry, which is question number 38. Question number 38 is this: highest salary in department. Okay, so this is our question number 38. Find the employee with highest salary per department. Output the department name, employee's first name with the corresponding salary. We are given an employee table. It has the employee details like ID, first name, salary, etc. etc. This is our expected output. We have to output the department, the first name of the top earning employee, and their salary. Okay, first I will write the pseudo code for this. First, open a CTE common table expression named name ranked salaries to calculate our rankings before our before we filter. Inside the CTE, query the department first name and salary. Third, generate a dynamic ranking using rank over partition by salary in descending order as rank. Finally, step outside the CTE and main write a main query to select the columns we need using where rank equals to 1 to strictly filter for the top earner in each group. Okay, let me write the code first. Okay, select rank salaries, select ranked salaries as select department first name salary rank over partition by department, order by salary in descending order as rank from employee. Select department first name salary and salary from ranked salaries where rank equals to 1. Okay, all right. Let me. All right. Question number 38 introduces one of the most frequently asked question in all of data engineering: top n per category. Before we have an employee directory with salaries spanning multiple different departments, we need a clean report displaying exactly who the highest paid individual is inside the every single department. The junior trap. When beginners see highest salary per department, they immediately try to write select department first name maximum salary group by department. This SQL will crash. If you group by department, the SQL has no idea which first name to display next to the maximum salary. You cannot keep individual row details intact when using a standard group by. We have to upgrade to Windows function. Because we cannot filter Windows function directly, we open a CTE called ranked salaries. Inside we select our columns, write our ranking engine as rank over partition by department, order by salary in descending order. The magic word here is partition by. This acts as a reset button. It ranks the sales team, and then the moment it hits the IT team, the rank resets back to 1. Now that every employee has a rank related to their department, we step outside our CTE. We write our main query, select department, first name, comma salary from ranked salaries. Finally, we apply our filter where rank equals to 1. This safely snipes the top earners from every single department while keeping all their details perfectly intact. When we hit run, okay, we have a syntax error in line number 6. Select node, select with. Okay, our code has been accepted. Okay, let's move to our next question, which is question number 39. Employee and manager salaries. Okay, I will read the question for you first. Find the employees who are earning more than their managers. Output the employee's first name along with the corresponding salary. We are given an employees directory which has all their details like ID, first name, department salary, and their manager ID, etc. And here is our expected output. We are expected to give first name of the employee who earned more than their manager and their salary as well. Okay, I will write the pseudo code for this first. First, set up your select statement to pull the first name and salary strictly from our employee alias even. Second, define your starting point from employee as even. This alias represents the subordinate workers. Third, third, perform a self join by calling the exact same table again, but with a different alias representing the bosses. Inner join employees as E2. Fourth, build the relation build the relational bridge on manager on even dot manager id equals to e2 dot id. This forces the database to place the employee row directly next to their specific manager's row. Finally, apply the filtering logic where E1 dot salary is greater than E2 dot salary to isolate cases where the subordinate out earns outruns their boss. Okay, I will write the pseudo code now. I will write the code now. Select even dot first name, comma, even dot salary from employee as even, inner join employee as E2 on even dot manager underscore id equals to e2 dot id, where even dot salary is greater than e2 dot salary. Okay, all right. Question number 39 is a classic interview staple testing, a mind bending concept, the self join. We have a single employee directory that contains regular workers and their managers all mixed together in same rows. We need to scan the single list and pinpoint any subordinate who is directly taking home a larger paycheck than their direct boss. When beginners read this prompt, panic sets in because they think, wait, I need to compare an employee to a manager, but I only have one table. The trap here is assuming you have two physical tables to do a join. You don't. In SQL, you can take a single table, clone it in database's memory by giving it two different aliases and join it back to itself. Our architecture, okay, I will explain the code now. Our architecture relies entirely on our aliases. We start from employee as E1 to represent our workers, and then we immediately inner join employee as E2 to represent the managers. Next, we need to bridge them accurately. We write on E1.manager.id equals to E2.id. This is critical. It ensures that John's row lined up exactly side by side with John's boss's row. Now that they are lined up, the math is simple. We add where even dot salary is greater than e2 dot salary. Finally, we jump up to our select statement and pull even first name and even salary, ensuring we are displaying the employee details, not the managers. We hit execute and we have flawlessly executed the self join. Now we move to our next question, which is question number 40, second highest salary. Okay, first I will read out the question for you. Find the highest salary of employees. We are highest salary of employees. Okay, we are given an employee table. It is a normal employee directory which has the employee ID, first name, last name, and many other details like their department, manager ID, etc. etc. Here is our expected output. We have to give, we have to find the second highest salary of employees. Okay, first I will write the CTE. First, the first build the inner subquery, inner subquery, select maximum of salary from employee. This silently calculates the absolute highest salary in the company. Second, step outside and write step outside and write the main query. select maximum of salary as salary from employee. We use max again to avoid computationally expensive sorting. Third, bridge them together using the where clause. Where salary is less than, by filtering for a salary strictly less than the absolute maximum, we instantly eliminate the top earners. The top earners, making the second highest salary the new maximum. Okay, I will write by writing the query. Select maximum of salary as salary from employee where salary is less than select maximum of salary from employee. Okay, all right. Question number 40 is quite literally the most frequently asked SQL question of the all time. Find the second highest salary. Before we have an employee directory with wide ranges of salaries, we need to output exactly one number representing the second highest pay grade, completely ignoring any ties at the top. The biggest trap here is to extract the single number. Beginners will try to select the distinct salaries order by descending order and use limit 1 offset 1. While this works for small datasets, sorting millions of rows just to skip one is computationally expensive and will make senior engineers cringe. You want to avoid sorting entirely. The most highly optimized way to solve this is with nested max subquery. We start inside the parenthesis, select max salary from employee. The database calculates this in a fraction of a second and find the absolute highest salary. Then we build our main query around it. Select max salary as salary from employee. We connect them using where salary is less than. By strictly filtering out the absolute highest number, we artificially remove the number one spot from the dataset. Therefore, when our outer query reaches for the max salary, the second highest salary is now mathematically the highest one left. No expensive sorting is required, and it handles data perfectly. When we hit enter, and when we hit enter, we get a beautiful green check mark and our solution is accepted. Now we move to our question number 41. Titan survivors and non-survivors. I will read out the question for you first. Make a report showing number of survivors and non-survivors by passenger class. Classes are categorized based on the P class values as as first class P class value 1, okay, second class 2, third class 3. Output the number of survivor and non-survivors by each class. We are given a Titanic table. It has passenger IDs there, whether they have survived or not, P class, name, gender, etc. etc. Here is our expected output. We are expected to give number of survivors and non-survivors by each class. First, I will write the pseudo code. First, select the survived. First, select the survived column as this will serve as the anchor for our final output rows. 0 for deceased, 1 for survived. Second, build our first conditional column. Some case when P class equals to 1, then 1, else 0 and as first underscore class. This scans the raw data, the raw data. This scans the raw data, flags the first class passengers, flags the first class passengers as 1 and mathematically adds them together. Third, duplicate this exact conditional logic for second underscore class and third class. Finally, pull from Titanic and apply a group by survived clause. This triggers the aggregation engine to collapse the dataset. running our three specific sum functions independently for both survivors and the non-survivors. Okay, I will now write the code. Select survived, comma, some case when p class equals to 1 then 1 else 0 and as first underscore class comma p class equals to 2 then 1 else and as second class some p class equals to 3 then some and as third underscore class from Titanic group by survived. Okay, all right. Question number 41 brings us to the famous Titanic dataset, which tests a highly requested technique, the pivot. We have a we already have a vertical list of all right, we are given a vertical list of passengers where their ticket IDs 1, 2, or 3 is stored as a ticket class 1, 2, or 3 stored as a raw number in a single column. We need to flip that vertical data horizontally, creating three brand new columns representing each class grouped cleanly by who survived and who didn't. When beginners are asked to count categories, they instantly default to select survived V class count star group by survived V class. But look at the expected output. The prompt doesn't want the class stacked in rows. They want them stacked horizontally as distinct columns. To transform our rows into columns, you cannot use a basic count. You must upgrade to conditional aggregation using case when. We start by selecting our anchor, the survived column. Next, we build our three horizontal buckets. We use some case when p class equals to 1, then 1, else 0 and as first class. This acts as a bouncer at the club. It checks the row, and if the passenger is first class, it hands them a 1 and it hands them a 0 if not. The sum function then adds all those ones together. We write the exact same logic for first class and third class columns. Finally, we'll tell engine how to cluster the data with group by survived. When we hit execute, we have flawlessly pivoted a vertical dataset into a stunning horizontal report. So our this question number 41 is over. Now let's move to our next question. Question number 42. Duplicate HR department employees. So this is our question number 42. I will read out the question for you first. Generate a list of employees who work in HR department, including only their first name, department in the output. Each employee should appear twice in the list, meaning their first name and department should be duplicated in the output. Each employee should appear twice in the list, meaning their first name and department should be duplicated by the output. We are given the worker table. It has worker ID, first name, last name, salary, their joining date and department, and is our expected output. We have to output only those list of employees who work in the HR department. Each employee should appear twice in the list, meaning okay, we have to duplicate it as well. First, I will write the pseudocode for this question. First, write the base query to select the first name and department from the worker table. Second, apply the where clause to strictly filter the dataset for department equals to HR. Third, drop down and use the union all set operator. This acts as the glue to stack multiple query results on top of each other. Finally, paste the exact same base query underneath the union all operator. Guarantee every HR employee is perfectly duplicated in the final output. Okay, I will write the code now. Select first name, comma, department from worker where department equals to HR. Union all. Select first name, comma, department from worker where department equal to HR. Alright, question number 22 is bit of a curveball. Usually we spend our life deleting duplicates, but today we have to create them. We have a standard worker directory with single entry per employee. We need a highly specific list of only HR department, but every employee must be physically duplicated, appearing twice in the final output. Okay, the interview trap. The trap here is fundamentally understanding how SQL set operators work. To stack data, you can use the union command, but standard union has a hidden feature. It automatically scans for duplicates and destroys them. If you use a basic union here, database will delete your second query and you will fail the test. To keep every single row from both the dataset, you are strictly required to use union all. Our architecture is uh, now I will explain the code. Our architecture here is very simple. Our We start with the top block. Select first name department from worker, where department equals to HR. This gives us a clean single list of HR staff. Now we drop our bridge, union all. This tells the database engine to get ready to stack next data exactly as it comes without running any deduplication algorithms. Finally, we paste the same query underneath. The SQL runs the bottom block, and smashes them together. When you hit execute, we have we have successfully force duplicated our data set. And now we move to our next question, which is question number 43, which is employees by same salary, employees with same salary. This is our question number 43. I will first read out the question for you. Find the employees who earn the same salary. Output worker ID along with first name and salary in descending order. We are given a worker table which has their worker ID, first name, last name, salary, joining date, and their department. Here is our expected output. We are expected to output the worker ID, first name, and salary of those employees who earn the same salary. I will write the pseudo code for this first. First, build the inner subquery to isolate the duplicate paychecks. Select salary from worker group by salary. Second, strictly filter that grouped subquery using the having count worker underscore id greater than 1 clause. This mathematically ensures our background list only contains these salaries that appear multiple times. Third, step outside and build the main query. Select build the main query because we are in the main query. We have the access to all the rows, to all the raw individual employee details. Fourth, bridge them, bridge them together using where salary in. This scans the whole company and only outputs the employees whose paychecks match our background list. Finally, organize the exact matches from highest to lowest with order by salary in descending order. Alright, I will write the code now. Select worker ID, select worker ID, first name, salary from worker where salary in select salary from worker group by salary having count of worker ID greater than 1, order by salary in descending order. Alright, question number 43 requires us to track down the duplicate paychecks without losing the identities of the employees holding them. We have a standard worker directory with names, IDs, and wide varieties of salaries. We need to target lists displaying the raw details of only the individuals who happen to share the exact same salary as someone else in the company, sorted from highest to lowest. So here is the biggest interview trap, group by crash. The absolute biggest trap here is trying to solve this single query by using group by salary. If you group by salaries together but try to pull the individual first name, SQL will crash. It cannot display multiple unique names on a single grouped row. To preserve the row level details like names and IDs, you must separate your logic, aggregate the salaries in the background, and pull the names in the foreground using a subquery. So I will explain you the code now. We start by writing our background logic inside a set of parentheses. We ask the database, select salary from worker, group by salary, having count of worker ID greater than 1. This silently generates a secret list of only the duplicate salary numbers. Now we wrap that into the main query. We write select worker ID first name salary from worker. To connect them, we drop in our filter where salary in. The SQL generates the duplicate list in the background, and then the main query scans every single employee, only letting them through if the salary perfectly matches a number on the background list. We finish order by salary in descending order to keep our leaderboard clean. Hit run. We have perfectly united subqueries with conditional grouping. Now let's move to our next question. Our next question is question number 44. April admin employees. It is an easy level question. Okay. So first I will read out the question for you. Find the number of employees working in the admin department who joined in April or later in any year. We are given a worker table. It has their worker ID, first name, last name, salary, joining date along with their departments. And here is the expected output. We are expected to give number of employees working in admin department that joined in April or later in any year. First, I will write the pseudocode for this. First, set up your aggregation. Select count star immediately immediately alias it as an underscore admins to strictly match the requested output format. Second, define the target table from worker. Third, apply the base filter for the departments where department equals to admin. Finally, add an and condition using the extract function by writing extract month from joining date, month from joining underscore date greater than equals to 4. We dynamically evaluate the month as an integer completely ignoring what year the employee was hired. Alright, now I will write the code. Select count star as n underscore admins from worker where department equals to admin and extract month from joining date is greater than equals to 5, greater than equals to 4. Okay. All right. Question number 44 is a great test for dynamic date filtering. We have a standard row uh, we have a standard worker roster with exact hire dates spread across multiple different years. We need a single count of administrative staff who joined specifically during the spring or later, meaning April onwards, regardless of year they were hired. The interview trap, hard coding years. The trap here is how beginners try to filter dates. Usually, people try to write something like joining date greater than equals to 2020 0401. But the prompt explicitly says in any year. If you hardcode a specific date string, you permanently lock yourself into that specific year and fail the test. We have to extract a month independently. We start with our select count star as an admins to set up our output. Next, we drop into our where clause and apply our first condition. The department equals to admin. Now, for the date magic, we use and extract month from joining date. This function acts as a pair of tweezers, reaching into the full timestamp and pulling out just the month as a pure number. January becomes 1, April becomes 4. Now it's just a number. We simply add greater than equals to 4 to capture April and every month after it, completely ignoring the year. Hit execute. Hit execute. We will have a completely bulletproof year agnostic data filter. Now let's move to our next question, which is question number 45. First name in 6 letters. Six, question number 45. First names with 6 letters ending in H. Okay, I will read out the question for you first. Find all the workers whose first name contains 6 letters and also ends with the letter H. Display all the information of the workers in the output. Here is our input table which you are given. It is the worker table. It has worker ID, first name, last name, salary, joining date, and department. And here is our expected output. We have to output those workers whose first name contains 6 letters and also ends with the letter H. Okay, I will write the pseudocode first. First, select star to pull every single column as requested by the prompt. Second, define the target table from worker. Third, apply the strict pattern Apply the strict pattern match in the where clause so that we can force the database to only accept names that are precisely 6 characters long and end with our target letter. Okay, we will solve this question using function length. Select star from worker where first underscore name like underscore 5 times or 5 h. Okay. Alright, question number 45 is an fantastic test of precision pattern matching. Before we have a before we have a employee directory with first names of all the different shapes and sizes, we have to extract full profiles of the employees whose first names meet two strict criteria. They must be of exactly 6 letter long and they must end with the letter H. The interview trap. The biggest trap here is the relying solely on the percentage wildcard. If you write where first name like percentage H, you are telling the database to find any name ending with the H. It will output 4 letter names and 10 letter names, instantly failing your test case. You must enforce the length. We start simply by select star from workers to grab all the data. Now we have two ways to solve this. We could use where length first name equals to 6 and first name like percentage h. Okay, we can also use where length length of first underscore name equals to 6 and first underscore name like percentage h and semicolon. This single elegant string mathematically guarantees that the name is exactly 6 letters long and ends with the letter H. When we hit execute, we have perfectly filtered our dataset. Now we can move to our next question. Let's move to our next question, question number 46. Count occurrences of words in drafts. Count occurrences of words in drafts. Find the number of times each words appear in the content column across all the rows of the Google File Store dataset. Output two columns, words and occurrences. We are given one table, Google File Store. It has two columns, file names and contents. And here is our expected output. We have to give number of times each word appeared in the contents column across all the rows in the dataset. Okay. First I will write the pseudo code for this. First, open a common table expression to handle our data transformation before we try to count anything inside the CTE. Use string to array contents, comma, apostrophe to chop the paragraphs into lists based on the spaces between the words. Third, wrap that function in unless to explode those lists horizontal lists into one massive vertical column into one massive vertical column alias this brand new column as word. Fourth, step outside the CTE and write your main query. Select word comma count star as occurrences. Finally, apply a standard group by word to cluster the matching text together and mathematically tally up the occurrences. Okay, now I will write the code with explode words as select honest string to array string to array contents contents must as word from Google file store. Select word count star as occurrences from explode words group by word group by word. Okay, we have a table filled with long horizontal paragraphs of text in the Google file store table. We need a clean of grouped vertical list showing every single unique word. used across the entire database along with the count of how many times it was written. The interview trap. The biggest trap here is not showing your advanced string functions. Beginners look at a paragraph and realize you cannot use group by a whole sentence to count the word the. If you do not know how to artificially create new rows out of the single string of, to the text, your interview ends right here. We have to build a CTE to transform our data. Inside, we use string to array contents. This scans the text and uses the space to chop the sentence into distinct list of words. But a list is still stuck in one row. To fix this, we wrap it in ultimate SQL magic trick, a nest. This function explodes the list, taking every single word and creating a brand new row for it in our database. We alias this vertical drop as word. Not that our data is vertical, the hard part is over. We step outside the city, right select word, count star as occurrences, and finish with the standard group by word. We hit execute. Okay, we have encountered an error here. Let me check what the error we are following. Okay, our solution was apparently wrong. So our solution was wrong because in the raw text the sentence starts with the letter capital the, but the expected output it perfectly groups it as lowercase the with the count of 4. Our ultimate regex sledgehammer perfectly handles the punctuation and the hidden characters, but the sequel strictly is case sensitive by default. It was treating capital THE and small letter THE as two completely different words, which means our grouping was fractured. So now I will write the correct pseudo code for this. First, handle the formatting trap. Wrap the contents column in the lower function so capital THE and small THE become the exact same string, become the exact same string. Second, hit it with the regex sledgehammer. Regex underscore split to table as word. This chops the entirely lowercase text at every single space, comma, or new line and drops the raw words vertically. Third, step outside into the main query. Select word count star as occurrences. Fourth, apply our safety net where word is not equal to apostrophe to permanently apostrophe space to permanently delete any blank ghost strings caused by double spaces or trailing punctuation. Finally, cluster the identical words together with group by word and organize the output with order by occurrences in descending order. Okay, so now I will write the code for this with cleaned explode did exploded words as select regex regex p split to table regex split to table lower of contents lower of contents lower of contents as words from Google File Store. Select word count of star as occurrences from cleaned exploded words where word is not equal to blank space group by word order by occurrences in descending order. Okay, So I will explain you this solution again. All right. This question is the final boss of text parsing, the case sensitivity. We have paragraphs filled with multiple random punctuation, hidden formatting, and standard capitalization, where THE starts a sentence and THE sits in the middle. We need a mathematically perfect, universally lowercase count of strictly the raw words, with absolutely zero punctuation and capitalizations skewing our data. The interview trap. When beginners finally figure out how to strip away the punctuation, they immediately run their code and fail the grader. Why? Because SQL is strictly case sensitive. If you don't standardize the first text, the database treats a capital THE and lower T THE as two completely different words, fracturing your final result. We fix this right at the source inside our CTE. We use our ultimate PostgreSQL function, reject split to table, but inside the parenthesis. We wrap our column in lower contents. This instantly forces every single character in the database into lowercase. Then we apply our universal regex slash capital W plus. Then we apply our universal regex scythe slash W plus to chop the text at any punctuation mark or space and drop the words vertically. Okay. Now that our text is completely uniform and vertically stacked, we step outside and write select word count star as occurrences. We drop in our safety net where word is not equals to space to delete empty ghost strings. Finally, we finish with group by word and order by occurrences in descending order to build a flawless sorted leaderboard of the text data. When we hit execute, again our code is not accepted. So I have figured out why our solution is wrong. Here I had to write regex p instead of regex. Now when I run my code, our solution is accepted and we have solved this super hard question. Now let's move to our next question, which is question number 48. So here is our question number 48, counting instances in text. So here is our question number 48. I will read it out for you. It is an hard level question. Counting instances in text. Find the number of time exact words bull and bear appear in the contents column. Count all the occurrences even if they appear multiple times within the same row. Matches should be case insensitive and only count the exact words. It is excludes substring like bullish or bearing. Output the word bull or bear and corresponding number of occurrences. Here is our Google file store table. It has two columns, file name and contents. And here is our expected output. We have to give how many times the words bull and bear appears in the Google file store table. Okay, first I will write the pseudo code first. Set up our text parsing CTE. We use regexp split to table lower contents comma apostrophe forward slash backslash capital W plus as word. This forces the text to lowercase and completely shatters the paragraphs into a clean vertical list of individual words, perfectly stripping out all punctuation. Second, step outside into the main query. Select word, comma count star as an entry. Third, apply the strict filter where word in bull, comma bear because our regex already split words like bullish into their own distinct rows, looking for the exact strings bull and bear naturally bypasses the substring trap. Finally, cluster the identical words. Finally, cluster the identical words together with group by word and organize the leaderboard with order by an entry in descending order. Now let's write the code for this. With cleaned explode words as select regex p split to table lower contents w plus as word from Google File Store. Google File Store. Select word, comma, count star as an entry from clean exploded words where word in bull, comma, where group by word order by an entry in descending order. Okay, I will explain this solution again. So, we have long paragraphs containing market analysis, full punctuation, capital letters, and varieties of words like bullish. We need a highly targeted count of the exactly two specific standalone words, bull and bear, formatted precisely under the column and entry. The biggest trap here is using the substring rule. If you try to use basic pattern matching like percentage bold percentage directly onto the roast sentences, you will accidentally count words like bullish or bulletin, instantly failing the text. You cannot search the horizontal sentence. You must shatter the sentence into vertical words first. We rely on the ultimate text parsing CTE. We wrap our contents in lower to standardize the pausing, to standardize the casing and drop it inside regex p split to table with W plus limiter. This scans the text and splits it into strictly at non-word characters, meaning bullish becomes one isolated row and bull becomes another. Now that our text is vertically stacked and separated, the substring trap is entirely neutralized. We step outside and write select word count star as an entry. We drop in our select filter. We drop in our filter where word in bull and bear. Finally, we finish with group by word. Hit execute. Okay, it is not accepted. Content. Contents. Okay, when we execute it, we have flawlessly extracted the financial sentiment keywords directly from the raw text. Okay, let's move to our next question, which is question number 49. Make the make the friends network symmetric. Make the friends network symmetric. For example, If 0 and 1 are friends, the output contain both 0 and 1 under 1 and 0 respectively. So we are given Google Friends network which has user ID and their friend ID. Here is our expected output. Okay, we are expected to give the symmetric network list of friends. First, I will write the pseudocode for question number 49. First, write the base query to select the original user underscore ID and friend underscore ID exactly as they appear in the Google Friends Network table. The Google Friends Network table. Second, drop down and use the union set operator. We specifically avoid union all because we want the database to automatically scan for and delete any pre-existing duplicate friendships. Third, write the exact same base query underneath but physically reverse the columns. Finally execute. Finally execute the database stacks the original relationships on top of the reversed relationships, deletes the duplicates and outputs a mathematically perfect symmetric network. Perfect symmetric network. Select user ID, comma, friend ID from Google Friends network. Union. Select friend ID as user ID, friend underscore ID as user underscore ID, comma, user underscore ID as for IEND friend ID from Google Friends Network. Okay. All right. Question number 49 is a classic network analysis problem straight from Google. Question number 49 is a classic network analysis problem straight from Google. Before, we have one way friendship directory. If user 0 follows user 1, we have we only have one row representing that connection. We want to force symmetry. If user 0 is friends with user 1, the output must also explicitly state that user 1 is friends with user 0. The interview trap. The trap here is accidental duplication. Beginners will try to reverse the column and stack them using union all. But what if users A and users B already mutually followed each other in the raw data? Union all will duplicate that mutual relationship. To create a clean, distinct symmetric network, you must use standard union to automatically destroy duplicate rows. Okay, now I will explain you the code. Our architecture is incredibly simple but powerful. We start with the top block. Select user ID, friend ID from Google Friends Network. This gives us the raw, original relationships. Next, we drop in our bridge union. This tells the engine to stack the upcoming data and aggressively filter out any duplicates. Finally, we create the bottom block, flipping the columns in reverse. Select friend ID as user ID, a user ID as friend ID. The SQL engine runs the reverse bottom block, smashes them together, and cleans up the mess. Hit execute, and you have flawlessly modeled a two-way social network. Okay, now when we hit check solution, our solution is accepted. We flawlessly modeled a two-way social network. Now let's move to our next question. Question number 50. So find drafts which contain the word optimism. Okay. Find drafts which contain the word optimism. We are given Google File Store table. It has two columns, file name and contents. And here is our expected output. We have to output the draft which contain the word optimism in it. So it is an easy level question. I will write the pseudo code first. First, setup select statement to pull both columns shown in the expected output, file name and contents. Second, point the query to the correct dataset. Third, isolate the draft files in your where clause, where file name like draft, draft percentage. This ensures we completely we completely ignore files like final dot txt. Finally, string your keyboard search together using an and condition and contents like percentage optimism, percentage wrapping the word in percentage, wildcards ensures the database finds it no matter where it sits in the sentence, no matter where it sits in the sentence. Okay, I will write the code now. Select file name, contents from Google File Store, where file name like draft percentage and contents like percentage optimism, percentage. Okay, all right. Question number 50 is the great reminder of how to combine multiple string filters clearly. Before we have a file repository containing various types of documents, including drafts and final versions, with the full paragraph of text. We need to filter this dataset down to display only the files that are explicitly drafts and contain the specific keyword optimism. The interview trap. The biggest trap on this question is skimming the prompt too quickly. Beginners will read, find the word optimism, and instantly write where contents like optimism. But look at the first word at the sentence. Find drafts. If you forget to filter the files names, your query will pull back the final .txt as well, causing you to fail the grader. Always read each and every word of the requirements, explaining the code. We start by selecting our columns, file name and contents. Next, we dive into our where clause to apply our double filter architecture. Finally, we first first we tackle the file type, where file name like draft. The percentage wildcard at the end tells SQL that string must contain the word draft. but you can end with any file extension or number. Second, we need a we layer. Second, we layer on our keyword search and contents like optimism. By putting a wildcard on both sides of the words, we tell the engine to scan the entire paragraph, flag a match word whether optimism is at the beginning, middle, or at the end of the text. We hit execute and we have perfectly targeted the search text search query. So finally we have completed 50 questions of our series. Now we move to our next question number 51. Processed ticket rate by type. Okay, I will read the question for you first. Find the processed rate of tickets for each type. The process rate is defined as the number of processed tickets divided by total number of tickets of that type. Round this result to two decimal places. So here is the preview of the table Facebook complaints. Facebook complaints, complaint ID, type and process. No, we here is our expected output. We have to find the processed rate of both the types of tickets. Let's write the pseudocode on the screen first. First, select the grouping column type. Second, construct the rate equation. Use a case statement to check if processed equals to true. To count the processed tickets, and divide it by count star to get the total tickets. Third, protect against integer division by outputting float values by outputting float values inside the case statement. Fourth, wrap the entire division calculation inside the round function to lock it to two decimal places. Finally, assign the alias as processed underscore rate and anchor the entire query with group by type. Okay, now let's write the code. Select type round off some case when processed equals to true, then 1.0, else 0.0, and upon count star comma 2 as processed underscore rate from Facebook underscore complaints. Group by type, group by type. Okay. So, alright, question number 51 brings us a classic Facebook product analytics problem. Calculating processing efficiency. We have a massive log of incoming user complaints marked as either processed or not processed using the boolean true false flags. We need a clean rounded leaderboard showing the exact processed rate for each single complaint type. Okay, the interview trap. The biggest trap here is you will handle the data types. The beginners see the values true and false in the preview grid and assume that they are text strings. Writing where processed equals true apostrophe true. Doing this will instantly trigger a type mismatch error causing booleans because booleans are raw logical states, not strings. You must drop the single quotes immediately. Okay, now explaining the code. We start our architecture with select type. Next, we build our metric. We take some case when processed equals to true, then 1 else 0, and notice two things. No quotes around true, and we use 1.0 instead of whole integer 1. This forces sequels to treat the numerator as decimal, completely bypassing the integer division track. We divide that sum by count star to get our total tickets and then wrap the entire fractional equation inside the round function. We make this metric as processed rate and group everything by group by type. When we hit execute, our solution is accepted. Now let's move to our next question, question number 52. Okay, finally let's move to our question number 52, number of violations. Number of violations. You are given a dataset of health inspections that include details about violations. Each row represents an inspection, and if an inspection resulted in a violation, the violation ID column will contain a value. Count the total number of violations that occurred at Roxane Cafe for each year based on the inspection date. Output the year and corresponding number of violations in ascending order of the year. We are given SF restaurant health violations table. It has columns like business ID, name, address, violation ID, violation description, risk category, etc. Here is our expected output. We have to give number of violations at Roxane Cafe for each year. Okay. First, I will write the pseudo code. First, set up your select statement, pull the year out of the timestamp using extract year from inspection underscore date and and alias it as inspection year. Second, calculate your metric count violation underscore id count violation id by targeting by targeting the specific column the specific column instead of a generic count star. The database will automatically ignore any null values, ensuring we only tally actual health code violations. Third, apply the strict base filter where BUSI business name equals to Roxanne Cafe. Roxanne Cafe. Fourth, cluster the math by the extracted year. Group by extract year from inspection underscore date. Finally, satisfy the chronological requirement by adding order by inspection underscore year in ascending order. Here is the code script. Select extract year from inspection date as inspection year count violation id as n underscore violations from sf underscore restaurants health violations dataset where business name equals to Roxane Cafe. Roxane Cafe. Group by extract from inspection year. Group by extract year from inspection date. Order by inspection year in ascending order. Okay. Alright. Question number 52 tests our ability to aggregate time series data while avoiding hidden null values. We need we have a massive detailed log of individual health inspection for restaurants across San Francisco. Alright, I will explain you the code again. Question number 52 tests our ability to aggregate time series data while avoiding hidden null values. We have massive detailed log of individual health inspection for restaurants across San Francisco. We need a clean chronologically sorted timeline showing the exact number of actual recorded specifically for Roxane Cafe year by year. We need a clean chronologically sorted timeline showing the exact number of actual health violations recorded specifically at Roxane Cafe year by year. The biggest trap here is how beginners use the count function. If you write count star, you are telling database to count every single row. But what if the health inspector visited, give them a perfect score, and left violation ID column completely blank? Count star will still count the rows as violation, completely skewing your data. You must count the specific column to naturally filter out the nulls. We start by Here is our code. We start by ripping the year of the times out of the timestamp using extract year from inspection date. Next, we calculate our metric with count violation ID, perfectly bypassing the null trap, alias it as n violations. We point this at our table and apply our strict filter where business name equals to Roxane Cafe. Finally, we group our data together with the exact same extracted year and anchor the bottom of our query with order by inspection year in ascending order. We hit execute and you have mathematically perfected and we have mathematically perfectly tracked this restaurant's violation history over time. Let's move to our next question. Next question is question number 53. Inspection of Gazelle coffee shop. Find all the inspection details made for facilities owned by Glassell Coffee Shop Limited Liability Company. Here is our raw data. Here is our raw data. Los Angeles restaurant health inspection. We have serial number, activity date, etc. in this and the owner name as well. And here is our expected output. Okay, we have to find all the inspection details made for facilities owned by Gazelle Coffee Shop Limited LLC. Glassell Coffee Shop LLC. Okay. So first I will start by writing the pseudo. First, use the universal wildcard. Select star to instantly grab every single column of inspection details without having to type them manually. Second, point your query to the correct database table, which is Los Angeles Restaurant Health Inspections. Finally, apply the strict base filter filter to isolate only the records tied to the specific, only the records whose owner name is Glassell. Now I write the code for this. Select star from Los Angeles Restaurant Health Inspections, where owner where owner name equals to Glassell Coffee Shop LLC. Okay, so question number 53 brings us to Los Angeles for a rapid fire data extraction problem. We have a massive table containing thousands of health inspection records across every single restaurant and facility in the city. We need a perfectly filtered report showing absolutely every detail, but strictly limited to the properties owned by Glassell Coffee Shop LLC. Okay, this is an easy level question. So the biggest trap on an easy level problem is its overthinking. When beginners manually type out 20 different columns because the prompt said find all inspection details, you don't have the time for that in an interview. When a prompt asks for all the details or all the columns, confidently deploy select star wildcard to save the clock. Okay, explaining the code. We start with blazing fast select star to lock in all our output columns. Next, we map it to our datasets from Los Angeles Restaurant Health Inspection. Finally, we drop in our strict string filter. We can scan schema, find the exact column holding the corporate data, right where owner name equals to Glassell Coffee Shop LLC, because we are looking for a perfectly exact corporate entity. A standard equal sign works beautifully here. We no need for a wildcard pattern matching. We hit check solution and our solution is accepted beautifully. So we move to our next question. Question number 54. Churro activity date. Okay, let's move to our question number 54. Churro activity date. Okay, first I will read the question for you. Find the inspection date and risk category for the facilities named Street Churros that received a score below 95. Okay, we are given a table of Los Angeles restaurant health inspections, which has different columns like serial number, facility name, score, description, employee ID, etc. etc. And here is our expected output. We have to output the activity date and description and risk category of the facilities named street churros. Okay, I will write the pseudocode for this first. First, set up your select statement to pull only the two highly specific columns requested. Activity date and PE description. Activity activity date and PE underscore description. Second, point your query to the correct dataset, which is Los Angeles Restaurant Health Inspections. Third, apply the strict base filter for the restaurant. Okay, where filter name equals to street churros. Finally, layer on the mathematical condition using an AND operator and score less than 95 by using the strictly less than symbol. We guarantee that a borderline score of exactly 95 is safely excluded from our risk report. Let's write the code now. Select activity activity underscore date comma pe underscore description from Los Angeles restaurant health inspections, where facility name is street churros. Facility underscore name equals to street churros and score is less than 95. Okay, all right. Question number 54 is a financial drill of layering multiple conditions. We have a massive table containing full health inspection details for every single restaurant in Los Angeles. We need a highly targeted risk report containing all the date and risk category specifically for street churros. Locations that scored below a 95. Okay, so the interview trap. The biggest trap on this question is missing the mathematical nuance in the prompt. It explicitly asks us for score below 95. If you rush and write below equals 95, you will accidentally include the facilities who scored exactly 95, failing the automated test case. Precision is everything in data extraction. Explaining the code. We start by shedding the weight of the massive table. We instead of select star, we only pull exactly what we need. Activity date and PE description. Next, we drop into our where clause to build our dual filter. First, we lock onto our target facility with facility name equals to street churros. Then we use AND operator to stack our second condition. Score is less than 95. This mathematically strict filter perfectly isolates the low scoring inspections. When we hit check solution, we have built a lightweight, highly accurate risk report, and our this question is over. So we move to our next question, question number 55. Most profitable financial company. Okay. Most profitable financial company. Find the most profitable financial company from financial find the most profitable company from financial sector. Output the result along with the continent. Okay, we are given this Forbes Global 2010 to 14 data, and we have to this is our expected output. We have to output the company which is most profitable in financial sector along with its continent. So next I will write the pseudocode for this. First, set up your select statement to pull only the exact two columns requested. Two columns requested. Company and continent. Company and continent. Second, point it to our dataset Forbes Global 2010 to 14. Third, apply the strict sector filter where sector is financials to eliminate other sectors. Fourth, rank the remaining financial companies by sorting them. Finally, chop off the top of the list using limit even to isolate the single most profitable company. Okay, so I will write the code for this. Select company, comma, continent from Forbes Global 2010 to 14, where sector equals to financials, where sector equals to financials, order by profits, descending order, limit 1. Okay, all right. Question number 55 is a Forbes global dataset problem, and it's a perfect test on how you handle finding the top records in the specific category. We have a massive list of global companies spanning dozens of sectors with their raw profit numbers attached. We need a clean single row output showing only the name and continent of the absolute most profitable company, specifically within the financial sector. Okay. The interview trap. The biggest trap here is trying to get too fancy with subqueries. If you write where profits equals to, select max profits, but forget to filter the subquery by financial sector, the database will pull the maximum profit of the entire world. If a tech company holds the global record, your query will look for a bank with tech company's exact profit, returning the completely blank table. Keep it simple and use a sorting shortcut instead. Explaining the code. We start by selecting our required columns, company and continent. Next, we immediately filter our table where sector equals to financials. Now that our dataset contains the banks and financial institutions, we don't need any complex math. We simply sort the data set from highest to lowest using order by profits in descending order. This pushes our heavy hitter right at the top of the table. Finally, we drop the guillotine with limit 1 to chop off the rest of the rows, leaving us with the single most profitable financial company on earth. When we hit check solution, we have a flawless, highly optimized query. Then we move to our next question number 56. MacBook Pro user event count. Question number 46. MacBook Pro user event count. Okay, it is an easy level question. Count the number of user events performed by MacBook Pro users. Output the result along with the event name. Sort the result based on the event count in descending order. So here is the table which we are given. Playbook events. It has columns like user ID, event type, event name, location, and device. And here is our expected output. We have to give the number of user events performed by MacBook Pro users. Okay, we have to output the result along with the event name. Let's write the pseudocode for this first. First, setup your select statement to pull the event name and calculate the metric event underscore name and calculate your metric. Alright, since it's an easy level question, I will directly write the code for this, then I will explain it to you. Select event name, comma count of event name as event count from playbook underscore events where device is equals to MacBook Pro, group by event name, order by event count in descending order. Okay. Alright, question number 56 is an Apple product analytics problem that tests your attention to detail on both filtering and formatting. Okay, we have a massive unorganized server log for each and every action taken by users across all types of devices. We need a clean, sorted leaderboard showing exactly how many times each specific event was triggered strictly by MacBook Pro users. The interview trap. There are two traps here. First, the prompt capitalizes MacBook Pro, but raw server logs almost always convert device string to lowercase like MacBook Pro. If you strictly copy the prompt's exact casing, you might return a blank table. Second, the prompt explicitly asks us for the results to be sorted. Beginners get so relieved when they successfully group the data. Then they hit execute without adding group by order clause, instantly failing the grader. Explaining the code. We start by building our core table. Select event name from our metric count of event name as event count. Next, we filter our data down to target demographics with where device equals to MacBook Pro. Now that we have isolated the correct users, we compress the data into distinct actions using group by event name. Finally, to guarantee we pass the automatic test case, we apply our descending sort, order by event count in descending order. We hit check solution and our solution is accepted. Now we move to our next question. Question number 57. Top 10 songs 2010. Okay. Top 10 songs in 2010. Find the top 10 ranked songs in 2010. Output the rank, group name, song name, but do not show the song. Do not show the same song twice. Sort the result based on the rank in ascending order. This is our table. This is our input table. Okay, I am not able. Okay, this is our raw table. Billboard top 100 year end. It has year rank, group name, artist, song name, and ID. We have to output the year rank, group name, and song name of the top 10 ranked songs in 2010. Okay, it's an easy level question, so I will directly write the solution for this. Select year rank, group name, song name from Billboard top 100 year end, where year equals to 2010. Order by year rank in ascending order. Order by year underscore rank in ascending order. Limit 10. When we run our code, our solution has been accepted. I will explain you this code again. Alright, question number 57 takes us to a Billboard top 100 dataset. We had a massive list of popular songs spanning multiple years with a known data quality issue in duplicate entries. We need a perfectly clean, deduplicated top 10 leaderboard strictly for the year 2010. The biggest trap here is ignoring the data quality warning in the prompt. It explicitly states do not show the same song twice. If you just filter by year and limit to 10, but the number one song is accidentally logged 3 times in the database, it will take up 3 of your top 10 slots. You must use distinct to compress those duplicate rows before the limit is applied. Okay, explaining the code. We start we start with select distinct followed by our three request columns. This acts as our data cleaning shield. Next, we map our table and drop in our strict time filter where equals to 2010. Now that we have a clean list of 2010 tracks, we build our leaderboard. We use order by year rank in ascending order to put to put number one at the top. Then we drop the guillotine with limit 10 to satisfy the top 10 requirement perfectly. We hit execute and we have a flawless deduplicated pop culture chart. We move to our next question. Customers with large orders. It is our question number 58. 58, 59, 60, 62, 60. Customers with large orders. The marketing team wants to identify high value customers for a premium loyalty program. Find all the customers who have placed at least one order of more than $100. Return customer ID and name. Order all or consider all orders regardless of their payment or fulfillment status. Okay. The marketing team wants to identify high value customers for a premium loyalty program. Find all the customers who have placed at least one order over $100. Return customer ID and name. Consider all orders regardless of the payment or fulfillment centers. Okay, we are given two tables. Online store customers that have their customer ID and customer name. And second table is of online store orders where we are given all the order ID and which customer ID has made the order with the amount and status. Here is our expected output. We have to find all the customers who have placed at least one order above $100. Okay, I will directly write the solution. Select distinct c dot customer ID comma c dot customer name from online store customers as C inner join online store orders as O on C dot customer ID equals to O dot customer ID where O dot amount O dot amount is greater than 100. Okay. Alright, question number 58 tests our ability to bridge multiple databases to build a targeted marketing list. We have two separate tables, one holding customer names and one holding massive amounts of transactional data. We need a perfectly clean, deduplicated list of customer IDs and name, specifically for the users who drop more than $100 on a single order. The interview trap. The biggest trap here is the many to is one to many relationship. A single premium customer might have placed 10 different orders over $100. If you just join if you just join the tables and filter by amount, that customer name the will print out 10 times and the marketing team will accidentally send them 10 identical loyalty emails. You must use distinct keyword to compress the final list. Explaining the code. We start by shielding our output with select distinct, grabbing only grabbing our two required columns, customer ID and customer name. Next, we map our tables. We start with online store customers and bridge over to our transactional table using an inner join. We log the relationship in using the shared key on customer ID c.customer ID equals to o.customer ID. Now that our data is connected, we drop our financial filter where amount is greater than 100. Because we have already deployed distinct up top, we can confidently hit execute and had and hand a perfectly clean list of VIPs over to the marketing team. C does not exist. Okay, our solution is accepted. Now we move to our next question. Question number 59. Departmental Workforce Analysis. Our question number 49. Question number 59. Department Workforce Analysis. The workforce planning team is analyzing department growth since the company's expansion, focusing on teams that have grown substantially. For each department with 5 or more employees hired after 2020, we return the name, headcount, total payroll, and average salary. This is our table, raw table, Tech Corp workforce. ID, first name, last name, department salary, and phone number, and joining date. Here is our expected output. We have to give the departments who have for each departments with 5 or more employees IDs after 2020 return the following things. Okay, I will write the code directly because it uh, okay. Select department count of ID as head count, sum of salary as total payroll, average of salary, average of salary as AVG salary from Tech Corp workforce, where year is after 2022, where extract year from joining date, joining underscore date is greater than 2020, is greater than 2020, group by department, order, group by department, having count ID is greater than equals to 5. Alright, I will explain you the code now. Question number 59 tests our one of the most fundamental concepts of SQL, the difference between filtering rows and filtering groups. We have a massive company directory of every employee, their hire date, and their salary. We need a high level financial summary, but only for departments that have recently hired at least 5 new people since the end of 2020. The interview trap. The biggest trap here is the order of execution. Beginners will try to write where count ID is greater than equals to 5. This instantly throws a syntax error because the database processes the where clause before it groups the data together. You cannot filter math. That hasn't happened yet. You must split your filters. Where handles row rows like dates and having handles aggregate math like counts. Explaining the code. We start by building our core architecture, pulling the department and calculating our count, sum and average matrices. Before we group anything, we aggressively filter our raw data using where extract year from joining date is greater than 2020. Now our working data set only contains fresh talent. Next, we compress that data with group by department. So all our payroll math executes perfectly. Finally, we weed out smaller teams by dropping in having count IDs greater than equals to 5. We hit execute. We have a flawless, highly optimized workforce analysis here. Let's move to our next question. Question number 60. Count information completedness. Okay, let's read our question number 60. Contact information completedness. The data quality team is auditing employees' records to assess the completedness of contact information. Calculate and returns ratio of employees who have null phone number. Here is our raw table Tech Corp workforce. It is an employee directory which has employees ID, first name, last name, department, salary, phone number, and joining date. We have to output this. It is our expected output. Okay, ratio of employees who have null phone number. Okay, I will write the code directly. Select 1 minus count of phone number upon count of ID numeric as null phone ratio from Tech Corp workforce. Okay, all right. Question number 60 is a data quality audit that tests our mathematical creativity in SQL. We have an HR database with some employees where some employees have phone numbers and some fields are empty, blank. We need a single precise metric, the exact ratio of employees missing their contact information. The interview trap. There are two traps here. First, if you divide a whole number by a whole number, SQL will return the fraction like 0.25 straight down to 0. You must cast to a decimal. Second, beginners will write a massive 5 line statement. It works, but it's slow to write. 5 line statement like some case when phone number is null, then 1, else 0, and we are going to use a faster mathematical shortcut explaining the code. We start by pointing our query to HR table from Tech Corp workforce. Instead of counting the blanks directly, we count what is actually there. Count of phone number gives us all the valid numbers and we divide that by count ID numeric, which is total head count. The numeric perfectly protects our decimal places. The fraction gives us the number of the people and the ratio of the people with phone numbers. To find our target answer, we simply drop a 1 minus at the very front of the formula. The mathematical inverse instantly giving us the exact number of missing phone numbers. We hit execute. We have we have brilliantly optimized the data audit script. Okay, we move to our next question. Question number 61. Users missing phone numbers. Okay, I will read out the question first. Users missing phone number. The product team is launching a new WhatsApp notification feature and needs to identify the users who haven't provided their phone numbers yet. These users will be shown a prompt to get their contact information. Find all the users who have not provided a phone number. Return the user ID and the name. We are given this table FinTech app users. It has three columns: user ID, username, and phone number. Here is our expected output. Expected output is this: user ID and username who have not provided a phone number. Okay, I will write the solution first. Select user ID, username from fintech app users where phone number is null. Okay, all right. Question number 61 is a classic operational data request from a product manager. Before, we have a complete database of all app users, some with verified phone numbers, some with empty records. We need a targeted list of only user IDs and names of the people missing a phone number, so we can trigger as in-app WhatsApp prompt. The interview trap. The primary trap of any question dealing with missing data is forgetting the underlying mechanics of SQL. Beginners will almost always write where phone number equals to null or where phone number equals to quote, single quotes. In database theory, null isn't a string or value of zero. It is absence of data. Because of that, standard comparison operators like equal sign completely break. You must use the designated is null syntax. Explaining the code, we keep our query incredibly lightweight by selecting only user ID and username directly from fintech app users table. To filter the rows, we drop our condition where phone number is null. The database scans the column, identifies every single account where the contact data was left blank, and hands us a clean, actionable list of our marketing campaign. Hit execute. You have a Hit execute. You have a perfect solution for this question. We move to our next question. Question number 62. Highest earners in support departments. Okay, here is our question number 62 on board. High earners in support departments. The HR team is reviewing the compensation packages of the employees in support functions. They want to identify high earners in HR and admin departments for a salary benchmarking study. Find all the employees who earn more than 80,000 and work either in HR or admin department. Return first name, last name, and department and salary. This is our raw data of HR table. It has ID, employees ID, first name, last name, department salary, phone number, and their joining date. And here is our expected output. We have to find all the employees who earn more than 80,000 and either work in HR or admin department. Okay, I will write the code for this now. Select first name, select first name, last name, department, salary from Tech Corp Workforce, where salary is greater than 80,000 is greater than 80,000 and department in HR and admin. Okay. Alright, question number 62 gives us an HR request where mixing multiple logic filters can easily break your code if you aren't careful. We already have a complete corporate workforce directory containing salaries across every single department. We need a highly targeted benchmark list showing only the names, roles, and payoff for the individual, clearing 80K specifically within HR or admin. The primary, the interview trap. The primary trap here is writing out where salary is greater than 80,000 and department equals to HR or admin. Because SQL processes and statements before or statements. The query would return high earning HR employees, but it would also return every single admin employee, regardless of how little they make. To beat this, you either have to wrap your departments in defensive parentheses, or yet better, use a clean in clause. Okay, we select our four matrices which are required directly from the Tech Corp Workforce table. To set up our filtering, we write where salary is greater than 80,000. Then, to layer on our department constraints safely, we drop in and department in HR admin. The in operator acts as a protective bucket, ensuring the database checks the department match as a single unit alongside our salary requirement. We hit execute and our and we have flawlessly optimized this solution, and here our solution has been accepted. We move to our next question number 63. Salary less than twice the average. Salary less than twice the average. Okay, it is a medium level question. Write a query to get the list of managers whose salary is less than the twice the average salary of employees reporting to them. For these managers, output their ID, salary, and the average salary of employees reporting to them. Here is we are given two tables. First table is of employee hierarchy. We have employee ID and their manager ID, and second table is dimension employee dim underscore employee. It is an employee table which has employee ID, their name, city, date of birth, pin code, and their salary. Okay, I will write the pseudocode for this question first. First, let's directly write the solution. Select h dot manager employee id as manager id manager underscore id. Okay, we are given two tables right here. Mgr dot salary as manager salary, comma average of employee salary as average report salary from map employees hierarchy as h inner join dime underscore employee as emp on h dot employee id equals to emp dot employee id inner join dimensions underscore employee as manager on h dot manager employee id equals mgr dot empl underscore id group by h dot manager underscore empl underscore id comma mgr dot salary having gr dot salary less than 2 multiplied by average emp dot salary. Okay, I will explain the code now. Alright, question number 63 takes us right into the deep end of the corporate organizational data structures. Before, we have a structured mapping table that contains pairs of employee IDs and manager ID, along with a separate master directory of employee salaries. We need a clean We need a clean dashboard identifying specific managers whose personal salaries are less than the double of the average pay of the team members directly reporting to them. The interview trap, the dual aliases trap. The ultimate trap of a hierarchy problem is getting confused by a single salary column. If you do not explicitly separate the tables into aliases, your database won't know if a salary belongs to subordinate or the boss. You must execute a double join, pulling from dime underscore employee twice, once under an employee alias and once under an manager alias. Explaining the code. We anchor our query on our mapping table. First, we perform an inner join onto employee table onto dime underscore employee as EMP using the standard worker ID. This lets us capture the salaries of the team. Second, we perform a completely separate inner join back into employee. This time aliased as MGR, matching on the manager's ID. This gives us the boss's salary. Now we cluster our data using group by h dot manager employee ID and manager dot salary. This isolates each team's leader. Finally, because we are comparing a raw manager's value against an aggregated team average, we must filter using having clause. Writing heavy, writing having manager salary less than 2 into average of employee salary. We hit check solution. Our solution is accepted. It was really a very good question. Now we move to our next question. Question number 64. Flags per video. Flags per video. For each video, find how many users flagged it. Unique users can be identified. For each video, find how many unique users flagged it. A unique users can be identified using the combination of first name and the last name. Do not consider rows in which there is no flag ID. This is our raw table users underscore flags. It has users first name, last name, video ID, and flag ID, and the expected output. So here is our video ID and number of users who have flagged it. Okay, I will write the solution first. Select video underscore ID count distinct concat user first name comma user last name as num unique users from user underscore flags where flag underscore id is not null. Group by video underscore id. Okay, all right, let's look at the question number 64. We are tasked with finding how many unique users flagged each video. The catch: a user is only unique if we consider the unique combination of their first and the last name. It is a perfect test of data cleanup and grouping logic. The interview trap. The biggest trap here is treating every row in the database as a single user. If one user flags the same video 5 times, count of flag ID will wrongly tell you that there are 5 users. You have to use count of distinct to ensure the individual only counts as one. The debugging moment. Now what happens if your count is lower than the expected? For example, if we expect 5 unique users but get 4, this is a common real SQL issue, data integrity. If your names have inconsistent capitalization or trailing spaces like John, like capital JOHN, capital DOE, and all small John Doe, the database sees them as different people or the distinct operator struggles to collapse them correctly. When your numbers don't add up, your next step isn't just to write more code. It's to inspect your data. The final solution. To get the official answer, we clean the data, combine the identifiers. We use concat to merge the first and the last names, wrapping that in count distinct to force the database to acknowledge them as a single unique entity. By grouping by video ID and filtering out the null flag IDs, we get a perfectly accurate count that passed each and every test. We will check our solution and our solution is accepted. Now we move to our next question. Question number 65. Maximum of two numbers. Question number 65. Maximum of two numbers. Given a single column of numbers, consider all possible permutations of two numbers with replacement. Assuming that the numbers x, y and y, x are two different permutations, then for each permutation, find the maximum of the two numbers. Okay, we are given one table, Deloitte underscore numbers, and here is our expected output. We have to output three columns: first number, second number, and maximum of the two. Let's write the solution for this. Select a dot number as number 1, b dot number as number 2, greatest a dot number comma b dot number as max number from Deloitte numbers as O as A, cross join Deloitte numbers as B. Alright. Question number 65 is a fantastic logic puzzle from Deloitte. We have a single simple column of numbers. We need a complete list of every possible two number we need a complete list of every possible two number combination including duplicates, and we need to identify the larger number in each pair. The interview trap. The main trap here is muscle memory. We are so used to writing inner join or left join with an on clause. But if you try to match columns here, you will only get the rows where the numbers equal each other. To generate all possible permutation, a Cartesian product, you must intentionally leave out the on clause by using a cross join. Explaining the code. We start by pulling numbers from Deloitte numbers as table A and we cross join it to Deloitte numbers as table B. If we have 5 numbers in the table, we will instantly generate a 5 on to 5 grid of 25 rows giving us every combination. In our select statement, we pull A dot number and B dot number to satisfy the final requirement. We skip the verbose case when logic and just use greatest A dot number and B dot number. And we check our solution. It is accepted and with a beautiful output table. Now we move to our next question. Question number 66. Number of shipments per month. Write a query that will calculate the number of shipments per month. The unique key of one shipment is a combination of shipment ID and sub ID. Output the year month in format YYY-1mm and number of shipments in that month. We are given this table Amazon underscore shipment where it has shipment ID, sub ID, weight, and the shipment date. We have to output the year month and the number of shipments in that month. Okay, let's write the code. Select to char shipment underscore date YYY dash mm as year month. Count distinct concat shipment ID concat shipment ID comma dash comma sub id as num underscore shipments from Amazon datasets from Amazon shipment group by to care shipment underscore date comma YYY MM order by year month year underscore month. Okay, so let's dive into our question number 66. Amazon logistics challenge. We have a massive table of tracking shipment dates, weights, and multi-part sub-IDs for packages. We need a clean monthly operational dashboard showing the year and the month and the exact volume of shipments handled. The interview trap. There are two classical traps here that flip candidates up. First, if you use group by shipment date, your data stays broken down by day, completely failing the product manager's monthly requirement. Second, if you only run a count shipment ID, you will miscount the actual volume because shipments are split across the composite primary key. With the sub ID, you must format the date and combine those keys, explaining the code. We transform our timestamp using two char shipment date YYYMM. This forces every single order in June to look identical as 2026-06. Next, to count the items without picking up duplicate logs, we run concat distinct. We run concat distinct. We count distinct concat of shipment date dash sub ID. This creates a completely unique string fingerprint for every true shipment package. We cluster the data using group by on our formatted month, sort it chronologically, and hit execute. Yeah, we get a flawless production ready timeline tracker that passes the grader on the very first try. Now we finally move to our question number 67. Question number 67. Question number 67. Write a query that returns the number of unique users per client for each month. Assume all the events occur within the same year, so only the month needs to be in the output as the number from 1 to 12. Okay, we are given the fact events table. It has multiple columns, and here is our expected output. We have to give the output that returns the number of unique users per client per for each month. Okay, so let's write our code. Select client underscore client underscore id, extract month from time id as month, count distinct user id, distinct user id as unique users from fact underscore events group by client id comma extract month from time underscore id. Okay, so this is our final question number 67. 67. We have a raw unfiltered log of tracking events containing full timestamp, client IDs, and user IDs. Okay, we need a simplified dashboard showing how many unique individuals interacted with each client during each calendar month, numbered from 1 to 12. The interview trap. The trap here is forgetting that you are operating across the two different dimensions simultaneously. If you only group by client ID, the database won't know what to do with the month column. If you only group by the month, the client data gets scrambled together. You have to ensure both dimensions are declared in the group by clause. Explaining the code. We start by pulling our client ID. Next, we need that 1 to 12 integer output. We skip string formatting and go straight to mathematical extract month from time ID. To prevent duplicate logs from artificially inflating our numbers, we run a count distinct user ID. Finally, we cluster our data by explicitly listing our client ID and our extract month down in the group by clause. We execute our code and our final question number 67 is over. I hope you liked my this 67 question series. This series had many easy and medium level questions. In the next video, we will be solving 15 hard level questions from data lemur. So I hope you like this video. Hoping you will benefit from this, and goodbye. Hope to see you in the next video. Bye.